Okay, so tonight we are going to look at probability, but mainly hypothesis testing is one of the interest areas. Though a couple of things might come in, okay? People had things to highlight, so we shall try and highlight them whenever we can. Okay, so today is Thursday. Thursday, December. And this is Probono 3rd. Okay, quickly, guys, kindly mute. Guys, kindly mute. Let's highlight the binomial distribution very quickly. The binomial distribution. So we are saying that this is a discrete distribution with the following.
That is at the gate.
With the following properties. Kindly mute. So one, the number of trials is known with certainty. Okay, and then each trial shall result in two mutually exclusive events labeled a success, that is P, or failure. And then the probability of a success shall remain the same throughout the experiment. Okay, and then we said that the probability of an occurrence at a given trial is independent of its occurrence. At any other trial. Okay, so a couple of things to recall that P plus Q shall equal to 1. And then the probability of a random variable okay, that follows a binomial distribution shall be given by, that is, i.e., X follows a binomial distribution NP, okay? Probability of X shall be N choose R, N choose R times, let me use the dots for multiplication, times probability P to the X times Qn minus R. Okay? Well, let's maintain the same thing. This is X. So where N is equal to number of trials, and then X is equal to number of successes or trial at which a success occurred. Occurred is double R or single R?
Single R.
Single R, thank you. Okay. So guys, how do I tell I have a binomial distribution? Okay, so that's one of the things. I don't know if one of the questions that I shared really brings it out. Let's see. Let's go there and see. Okay. One or two questions. Someone may tell us which one it was. Okay.
Francis,
Yes, sir.
can you scroll up a bit?
1 second, brother. 1 second.
All right. Okay.
I'm looking for binomial distribution here. Okay. You see this one here? You see that? November 2014. Do you see that?
Yes.
Okay. And then part C was for approximation to normal distribution. Okay, so we are gonna see it. We are gonna see it. The gentleman wanted us to scroll a little bit so he can follow us. Let me see. Up to where, sir?
Francis, your screen has disappeared.
No, it's back on.
I can no longer access it.
The screen
Hmm?
is
This
on.
side,
Come again?
for me, I can no longer see it.
Okay, quickly. I'm going to help you here. Let me see what I can do.
The screen is on.
Let's help him. Let's help him. Okay, in 2-3 minutes. Can you see it now?
I still can't see it.
You can now?
No, I still can't see it.
He needs to refresh his side.
Okay, refresh your side.
Okay, let me try refreshing it.
Okay. Okay, guys, we didn't define one of these. P is equal to probability of success. And then Q is probability of failure. Okay, so we know that P plus Q is equal to 1. So I'd put a question across. This one here. May someone online read for us, please? November 2014.
Can I read?
Yeah, please go ahead.
This is November 2014. At Go Back Well Clinic, on average, 20% of the patients in private rooms have health insurance. Assuming X to be the number of insured patients, where X is equals brackets 0, 1, 2, 3, 4, close brackets, required. Use a binomial distribution to determine the mean and the standard deviation.
Keep going.
And then B2, determine the probability distribution function and the cumulative distribution function.
Good job. So quickly, let's first go back here. I'd left out something. Let's see it. Okay, so mean and variance of a binomial distribution. So A is the mean. So mu is equal to NP, and then B, variance, sigma squared. Sigma squared shall equal to NPQ. Okay, so we go to November 2014. November 2014. Let me see, how do I get there?
2014, which question?
Kindly mute. November 2014 is what we are doing. You must have a calculator, guys, okay? So you can see how we compute these things, the figures. Okay, when you look at this question, what is our N? This is November. Our example is November 2014. Question 2B. When you look at that question, they are telling us that X is equal to 0, 1, 2, 3, and 4. What is our N? So this is B part 1. Come again?
N is 5. N is 5.
Come again?
N is 5.
N is 5. Okay. Any other?
4.
Someone is saying N is 4. Any other? Okay. This guy says, let me take you back.
N should be 4. We remove the 0.
N should be 4. Okay. November 2014. So the guy says that at Go Back Clinic, on average, 20% of the patients in private rooms have health insurance. Assuming X to be the number of insured patients, okay? This is number of insured patients. So number of insured patients may be 0, maybe 1, 2, 3, or 4. My question is, if he was to check for insured patients, okay, for any characteristics of insured patients, how many patients will he check?
He will check for 1, 2, 3, and 4.
He will check for 4. He will check 4 patients. Okay? He will check up to 4 patients. Are we together? I hope I'm clear at that.
What if he doesn't? Francis, what if he doesn't check and
That is the 0 you see there. That 0 patients were checked. 0 patients were insured. You know what I mean? So our N is 4. Now, he's asking for to determine the mean and standard deviation. So our mean mu is equal to NP. What is P?
0.20.
Come again?
0.2.
0.2.
Okay, so thank you. 20%, which is 0.2. So mu will equal to 4 times 0.2. Therefore, our mu is equal to 0.8. Okay. And then he wants mean and standard deviation. We know that standard deviation is equal to square root of variance, sigma squared. And we know sigma squared is N what? NPQ. Okay. So sigma squared will equal to, can someone help?
4
4 times
Times 0.
times
0.2 times 0.8.
0.8.
Yeah.
Okay, if you remember, P plus Q is equal to 1. So 0.2 plus Q is equal to 1. Therefore, Q would be 1 minus 0.2 to have 0.8. Okay, so sigma squared will equal to
0.64.
0.64, meaning sigma, which is root of 0.64, would be what?
0.8.
0.8. So our standard deviation is 0.8. Okay, good people. Before I proceed, there's a statement I wrote here. There's something I wrote here. I hope you picked it. You see this? Where we say X follows a binomial distribution NP. So this N here, if they wrote, like for instance, in this case, we can write it as in that format. We can write that X follows a binomial distribution with 4 and then 0.2.
Back the mangoes to the kitchen.
Do you get that? Kindly mute. Kindly mute. Please mute.
Wait.
Okay. My challenge is, guys who have unmuted, you're going to be asking me questions, okay? Because I'm getting into a bit of a delicate area where you'll need to use the calculator.
Darikunda, please mute.
So you'll come back to, ask me questions of the same. How did you get this from a calculator? So kindly mute and listen, okay? Good, thank you. Okay. So, guys, the guy may write like this and tell you that maybe the number of people registering for your course follows a binomial distribution, and then he writes X, B, and then he will say 16, 0.75. This will be your P, and this is your n. Okay, so that's the standardization of how to write it. Okay, so just be mindful. Okay, nice. The guy's next question is what? What's his next question? He's asking us to do what?
Determine the
Determine
probability distribution function, the cumulative
and the
distribution
cumulative
function.
distribution.
Okay, so we move in here. So the probability distribution function, you need to determine the probability of, this is how it's gonna be. He needs the probability of 0, okay, having a private ward, 1 having a private ward, 1 patient in a private room, 2 in a private room, 3 or all 4 in private rooms. Okay, so that's the probability distribution. So 2. So for the probability distribution, we know that probability of x is equal to n choose x times probability x times q n minus x. Now, probability x equal to 0 will equal to 4 choose 0 times 0.2 to power 0 times 0.8 to power 4 minus 0. So this is 4 choose 0 times 0.2 power 0 times 0.8 power 4. Can someone help us to 3 decimal places? What do you get?
0.041.
0.041. In case you have a challenge, kindly raise it so we can show. Now, let's go on our calculators. On your calculator, you'll type 4 and then you shift. You go to the division sign. It has NCR. The shifting means you want to pick NCR. So for shift, type the division sign, and a C will come on your screen, and then type 0. Then times 0.2, hyphenation. There's a power symbol on your calculator, a button. Okay, this button here, you press it, and then times 0.8. Again, usually you may put it in a bracket, then hyphenation 4. Okay, good. Just in case of anything, please let us know. Okay, probability x equal to 1 would be 4, choose 1, times 0.2 power 1, times 0.8 power 4 minus 1. This is 4 choose 1, times 0.2, times 0.8 to the power 3. What do you get?
I'm glad you pointed that out, Ironhope. And sorry for not listening earlier, Ironheart. I'm sorry too.
0.40. 0.41.
0.441. Okay, probability x equal to 2 would be 4 choose 2 times 0.2 to the power 2 times 0.8 to the power 4 minus 2, which is 4 choose 2 times 0.2 power 2 times 0.8 to the power 2.
Choose 2.
0.15.
0.15,
15.
right? Okay. Then probability x equal to 3 would be 4 choose 3 times 0.2 to the power 3 times 0.8 to the power 4 minus 3, which is 4 choose 3 times 0.2 power 3 times 0.8 to the power 1. Okay.
0.02.
0.02. And then lastly, probability x equal to 4 will be 4 choose 4 times 0.2 to the power 4 times 0.8 to the power 4 minus 4. So this would be 4 choose 4 times 0.2 to the power 4 times 0.8 to the power 0. What do you get?
0.0016.
0.0
0.0016.
0.0
Zero.
another 0
Mala zero,
Yeah.
yeah.
1
Then 1.
Okay.
Me?
Can someone
I
check
failed
the
to get I failed to get the answer for the first.
first one? The first one is what?
0.41.
0.41. That's what it was also, eh? So how many decimal places?
Carol, kindly.
And 9. Hello, Carol. Carol, kindly mute. Okay, thank you, Carol. You can always unmute when you are contributing, please. So you are giving those values to how many decimal places, guys?
3 decimal places.
Or to 3?
So 3,
So
then you round them.
0.41 was what?
It was 0.409.
9 what?
6.
9, 6, okay. 0. Let me take 4 for now. I just want to show you something. 0.4096. How about this one? Was also 0.496?
Yes.
Okay. How about the one for 2? To 4 decimal places.
Zero point 1536.
0.1536. And then this other one was what? 0.0.
0.0256.
56.
Yeah.
Okay, and the last one was 0.0016. Guys, when you add these things, you should get a 1. If you don't, then you made a mistake somewhere. Okay, because here you've considered each and every one. What do you get?
We get the 1.
You get 1, eh?
Yeah.
Okay, so going by the 3 decimal places, this would this also would be 0.15. This would be 0.0. So again, when you add these, you should get a 1. But I just wanted you to see. You may get something lower than 1, but due to the rounding offs, if you added the ones in red, they could generally be because of the rounding off. But literally, it should come up to 1. Okay? I hope I'm clear, good people.
Okay, so I have a question.
Yes, please.
Does it mean when they ask for a distribution, we use Poisson distribution? Like how we
What do you
have
mean?
calculated?
This is
In the formula.
binomial. This is binomial.
That's binomial.
Okay. What is a probability distribution? A probability distribution is a table or a graph that shows the variable together with its likelihood of occurrence. So this guy has a variable, which is number of patients with private rooms. So these patients here is telling you, you show me their probability distributions. So you're going to come here. You're going to come here. You're going to come through and say X, then probability of X, and then the cumulative probability of X. Monfuna. Do you get me, guys?
Yes.
Yes, please.
So you had 0, 1, 2, 3, and 4. Probability of X here is what?
Zero point 4096.
4096.
Okay. 0.4906. Let's take 0.4, pardon me, 0.41. We are taking 3 decimal places. This is also 0.410. For 2, are you following? 0.154. For 3, it is 0.026. And lastly here, it is 0.002. Is that so? Yeah, 1, 5.
Excuse me, sir.
Yes, please.
I'm sorry for taking you back. I would like to ask, why did we use 4 as our n?
Okay, just a second, brother. 0. I'm just writing these probabilities right, okay? Just a second. 0.26. 0.026. This is a 6. And this is a 2. Okay, yes. Let me maintain 3, 4, to be more exact. I'll keep 4. In the exam, you can keep 3, but here, for purposes of queries, I'll keep 4 for exactitude. 0.26. 0.2256. 0.016. Okay, why did we use 4? Okay, good. The person that asked, can you read again that question?
At Ago Backwell Clinic, on average, 20% of the patients in private rooms have health insurance. Assuming X to be the number of insured patients, where X is 0, 1, 2, 3, 4.
Okay, now right there. In a private room, okay, this is what you'll find. You may find 0 insured patients. You may find 1 insured patient. You may find 2. You may find 3 or 4. Okay? So the highest number of patients you can count in the private room is only up to 4. So if I wanted to know the number of insured patients that received treatment, I can go up to only 4. I don't know if you get my argument.
Yes, I'm getting.
So in the room, I may not find any insured. Sorry, in a private room, I may find 0 patients in a private room. But this private room can only accommodate up to 4 patients that are insured. I don't know if I make myself clear.
Yes, it's clear.
Okay, good. So it's like saying people having a 5-work day. Okay, and I would like to know on which days people are late. Finding someone late on which days. So there may be on a day where I find 0 late, then 2, 3, 4, and 5. So I'm checking up to 5 days. Now you can turn it into number of people that I'm checking for only up to 5 people. I assume in a day, at least one person is late. Okay. So the number of times, the number of trials here will be 5. Okay, I hope it shows a bit of clarity. Let me know when you're still challenged.
Excuse me, Mr. Francis.
Okay. Yes, please.
Kindly help me reset my calculator as if somebody put it wrongly. It brings
we are going
B,
to
a small
we are going to
B
do
and I plus a question mark.
Come again?
It brings a small B, a 1, and a question mark wherever I press it.
Okay, can you take a screenshot and share in the group?
Okay.
Take a screenshot and share in the group.
Okay.
A picture. Okay. So guys, this is gonna be 0.4. You determine the cumulative frequency. What will this one be?
Zero point 8192.
8192, and then this will be
9728.
0.9728, and then this will be
9984.
0.9984, and then lastly
1.
1. Okay, nice. Guys, you may further be asked to determine maybe the mean. After you've determined the probabilities, they may ask you for expectation. Okay? Someone asked that question of expectation. We all know that expectation is equal to summation of X times probability of X. Okay? So our X is here. We just need the X times probability of X. What is 0? You multiply this with that. What do you get? This will be 0. Next is what? 0.4
0.
0.96, right? And then next will be
0.3.
0.3
0.72.
0.3072.
0.72. And then next will be 0.768. 768. And then lastly,
0.00.
0.0064. Can we add that?
Zero point eight.
0.8. What did you get here as your mu?
0.8.
You see that?
Yeah.
Okay, perfect. So our expectation is equal to 0.8. When they ask you for variance of x, I know this, you know, sigma squared will be summation x squared times probability of x, okay, minus summation of x times probability of x, but everything squared. You know what I mean? So you'll need a column here for x squared times probability of x. Does it make sense to you guys? Will you try it out in your free time?
Yeah.
Yes, we will.
Okay,
Yes.
please do. But in case you are challenged, let us know as we move. Okay, the next question. Yes, please.
Excuse me, sir. I have a question.
Yeah.
Assuming in the question they did not tell you whether to use Poisson or binomial, how do you identify that I need to use Poisson or binomial? Because there are some questions where they don't tell you that.
Okay. If you can allow us do a Poisson so that you see vivid differences, I think that would help. Then I can come in. But a quick one. The binomial distribution will give you a probability of occurrence. This is one of the properties you wrote, that the probability of success shall remain the same throughout the experiment. So here, the probability that you will have patients in private rooms was 20%. It was known. Now, even under a Poisson, you may be given a probability, but in most cases, for a Poisson distribution, the probability is usually less than or equal to 0.5%. It's usually small as compared to the probability of a binomial. You get what I mean?
Yeah, I do.
And then on another note, the Poisson distribution uses average occurrences. If he does not give you average occurrences, he will give you a probability and then the number of occurrences which are very big. In a binomial, when you see number of occurrences that is really big, you need to approximate to a normal distribution. Because someone was actually asking, when do we approximate to a normal distribution? So for a Poisson, okay, they'll give you a probability which is small, okay,
If it is big, the number of occurrences may be small. And then the probability is small, but number of occurrences is very huge. Maybe in our real life, when do we have a binomial distribution? When do we have a Poisson? The Poisson distribution, or under the Poisson distribution, you do not know the number of times you're going to perform the experiment until the experiment is done. What are we talking about? Take an example of someone who works at a call center. When he's starting their day, do they know the number of calls they will receive? Yes or no?
No.
No, they don't know the number of calls they will receive. Even yourself, when you are starting your day, you don't know how many people are going to call you. Take an example of also a hospital. It does not know the number of patients it will receive in a day. But when the day has ended, they can now do a count. So if you are to take it for a month, they'll use likelihood of occurrence, and they use averages. The binomial distribution, you know with certainty. Guys, if you could only mute, please.
Your microphone.
If you could only mute. Now, for a binomial distribution, where do we have such an opportunity? I'll give you an example. A mother giving birth to either a baby boy or a baby girl. We know that is a 50-50. That the child will either be a baby boy or a baby girl before even birth is done. Okay, so that means our P is 0.5%, or sorry, is 50%. Unless otherwise, where someone tags the chance, he will say the chances of having a baby boy are 80%. When can that happen? It can happen, maybe they have gone to a fertility center, which creates higher chances of having a baby boy or a baby girl. Or probability of having one child and twins. That is also 50%. It's either one child or twins. It's 50%. Or if they went to a fertility center and these babies can be, fused into the mother's womb, they say, we are going to have twins. And they'll tell you that your chances of having twins are probably 75%. Then it changes. But still, you know the chances of the success before the experiment is what? Is performed. That is under the binomial. Take another example of someone being late for work. Okay? So when you're observing these people, you will say, I'm going to observe Francis for the next 5 days. So you know the number of times you're going to observe him, as opposed to where phone calls are coming in on a call center. Where phones are coming on a call center, that's a Poisson distribution. You cannot tell how many calls are going to come in. Where are you going to observe a person and you've put, a number of timing? You're saying, I'm observing him for 5 days. That's a binomial. You know the number of times you're performing the experiment before it's actually done. And then chances of being late or early are 50-50. So you'll say his chances of being early are 50%. Unless otherwise you say our company provides a company vehicle and it picks them early. So there is no way Francis can be late. So you would say, I'm tagging chances of him being early as 80%. Okay, so that means you have set the experiment with its parameters already. You know how it's going to be done. The chances of being early and the number of times you're going to observe this person. That's a binomial. A binomial distribution is also called a priori distribution, priori. And then the Poisson is a posterior, post meaning after you've performed the experiment. I don't know, guys, with that, if you get a better example of what I'm talking about. Okay. I don't know which roads you use, but God forbid, let's assume on a particular road, accidents happen or cars are using that road, okay? It's until the week has ended, then you start to count how many accidents did we have on a particular road. Is. Poisson binomial. Was I clear?
Yeah, sir. It was well elaborated.
Okay.
Thank you.
Nice. Nice.
Mr. Francis, I have shared the pic of my calculator.
Oh, okay. 1 second. Let's get it. Okay, so I would like you to press the mode button.
Yeah.
Are you there,
I've
brother?
pressed it. Yes, I'm there,
You
sir.
you press this button here.
Yes,
Okay.
I have pressed already.
Give me a minute. Give me a minute. Okay, brother, are you there?
I'm there, sir.
Okay, so press until you have until your calculator reads, until the screen reads fixed, science, and then norm.
Yes, I'm there.
Press 3. It is having 1, 2, 3. Press 3 and then 2.
It is bringing a one question mark. One.
Press 1.
Instead, I press 1.
Yeah.
Thank you. I think it is okay
What
now.
do you have?
I have a 1. I have a 1. As if it has normalized now.
Okay, sounds good.
Thank you,
Sounds
sir.
good. You too. Thanks for asking. Okay, guys, together, approximation of a binomial to a normal distribution. Approximation of a binomial.
Excuse me, sir. Sorry,
To a
I'm on the
normal.
road, but I want to ask something.
Yes.
You see how we used 4 when we were doing the binomial distributions? I thought why we are using that is because the characters are what I thought, yeah. Yeah, like that 0, 1, 2, 3, and 4.
Yeah.
So do we just choose the highest one? Sorry, I was moving, that's why I couldn't pick it up so well. Just
Literally,
we just choose the highest one.
Okay, let's put it to bed. Literally, 0 is counted as an occurrence. Chances that you have 0 success. So that means you do not count the 0 because literally nothing happened. You had 0 opportunities. So your count actually starts from 1 up to 4, but you need to take on the probability that you had 0 opportunities of what you are looking for. Is that okay? So when you say you take the highest, yes, I can say that as a literal answer. It is true. You take the highest.
Yeah, why I'm asking is I could literally take 5 as my end, since there are 5 characters. That's why I'm asking.
How many, just a second, how many occurrences do you have? In other words, how many patients do you have? You do not have 5 patients in the room. If you went in the room and opened it, there is a chance that you'll find 0 patients. You won't find a patient. Are you with me?
Yes, I am.
And then there are chances that you'll have 1 patient, you'll find 1 patient, 2, 3, or 4. You cannot find more than 4 patients because it's not mentioned here. So the literal answer, like I told you, you can go by the highest as you said it, okay?
Okay, I get it now. Thank you.
But never forget occurrence 0. Okay. Sounds good. So here we translate a discrete distribution that is binomial to a continuous distribution, which is normal, by use of a correction factor plus or minus 0.5. Okay, turns out some people do not know that they are unmuted. Let's remind them. Okay. Zubairi, kindly mute. James, kindly mute. And Slivia. Thank you, guys. Yeah. James, kindly mute. I don't know if you're contributing something. And Slivia, kindly mute for now, please, just in case. Nemwe mujja kwogera ebyama tubiwulire eno tubasookeyo gye mugenda obbikima. We may go there faster. We shall hear the conversation and we go there earlier than you did. Mwegendereze when you unmute. We shall go and pick that money. You joke. Okay, thank you. Thank you, though. So now, very quickly, guys, a binomial distribution is a distribution of countables. That's why we are calling it a discrete distribution. Number of cars, number of people, number of mangoes, number of fruits, name it, where you are counting. When it comes to a normal distribution, it's a distribution of continuity. Okay, it comes from a cumulative frequency curve. So now here, when you're going to do a translation, you cater for the error term, which is a plus or minus 0.5. And I would like to repeat myself, okay? So, for instance, we have a reading from a binomial distribution and want to transfer it to a normal by using a plus or minus. Okay, so in the first place, where the binomial says that x is greater than 60, okay? For continuity, in other words, x cannot equal to 60. Shall we subtract 0.5 or we shall add it?
We shall add it.
We add it.
We shall add it. Okay?
Yeah.
So here you add 0.5 so that x under the normal reads x is greater than 60.5. Okay? In other words, as you come from up going forward, you should never cross 60. This is telling you x must be greater than 60. So when you go to a normal distribution where you have continuity, it should read above 60. Okay. 2.
Excuse me, Buzz. Is it
Where
greater
x
than
is
or equal
greater
to,
or equal to
greater than?
60. Yes, please.
For the first one, is it? Okay, I'm just wondering, shouldn't it be x greater than or equal to 60.5? Or it just remains greater than?
Greater. You see, the binomial is telling you that x must be greater than 60. So you are translating it to a continuous distribution. In other words, as you are picking every value, a value 60 should not be picked. Okay, so that means it starts off above 60. Do you get me? So the correction factor should be added. Do I make myself clear?
Yes.
Okay, now the next one. The binomial says that x is greater or equal to 60. In other words, as you move upwards, you must cross 60. So, should we subtract or we add 0.5?
We subtract.
Good job. So we shall subtract, and it will read x is greater than 59.5. Here you subtract 0.5. Munfuna.
Yetukufuna.
Okay, good job. And then 3, if x were reading less than 60, remember, if x is less than 60, it means x cannot be 60. So as I go down, I should not cross 60. As I reduce, I'm going down. X is less than 60. X should not cross 60. Should I add or subtract?
Add.
You less.
You less, so that it is
You
less than 60. So it will be x less than 59 point what? 0.5. Are we at par? Okay. 4. If it read x less or equal to 60, remember, x must be less or equal. In other words, as I come from up going downwards, I must cross through 60. Question is, do I subtract 0.5 or I add 0.5?
You add a
You add
0.5.
0.5.
You add. Good job. So it will be x less than 60.5. In other words, as I drop from 60.5, this 60 is going to be crossed because it's telling you it should be less or equal. Okay, good job. 5.
Excuse me, sir.
If x is equal to 60. Yes, please.
I always have a problem with that x is less or equal to 60 because I thought that since it is less or equal to, we shall have to cross 60. We shall have
Yeah,
to
that's
have
it.
60.
You'll have to cross 60. So if x is here and 60.5 is here, as you come down, you are going to cross a 60 somewhere here. Is that okay?
Okay, so I thought we were supposed to list, because if we're if we list, then we would go to a lower value. That is my thought.
Okay.
That was my thought.
Tell me, what figure would you have if you list?
59.5.
Okay, good job. So you are coming from 59.5. You are going to leave 60 here. Yet they are telling you it is either equal or less than 60. But you've left out 60. You are here. And you are going downwards. Do you get what I mean?
I get you. Thank you. It's okay.
So it's preferably you start from a higher figure so you can cross 60.
Okay, all right. Thanks.
Okay, good job. Okay, now this one is a bit perturbing, yet easy. Look, for x equal to 60, this is our x equal to 60. So I have an x1 here and an x2. This is the question. If x equal to 60 is here, is x1 less than 60 or it's more than 60?
X1 is less than 60.
Okay, x1 is less than 60. Thank you. And then if x2 is here, is 60 less than x2 or it is more?
It's less than x2.
It's less.
Thank you. Okay, so I'm going to write the two things. The first one is x1 less than 60. Okay? So for less than 60, and I'm transferring it to a normal, what should x read? Less than 60. What should it be?
59.5.
Thank you. X is less than 59.5. Okay. Now, the last one is 60 is less than x2, meaning x2 is greater than 60. What will the binomial read, the normal read?
X is greater than 60.5.
Good job. X is greater than 60.5. So that means this here will be 59.5 and this will be 60.5. So we shall have, I'll write it in red. 59.5 is less than X, less than 60.5. That's what you need to compute. Okay. For that matter, we go in and try an example. Kindly ask where it's not clear. So we move into this question. It was a continuous question. Can someone read for us part C?
In a certain town, 36% of its 7,000 workers belong to trade unions. The town clerk took a random sample of 100 workers in order to find out the number of workers who belong to the trade unions. Required, by approximating a binomial distribution to a normal distribution, find the probability that the number of workers who belong to trade unions will be from 24 to 42.
Okay, perfect. Within here, can we try to summarize together? What do you see?
P
P
equals to
0.36.
P is equal to
0.36.
0.36. Good job.
N
N
equals to 100.
N is equal to 100. Good job.
Q equals to 0.64.
Okay. So thank you. You are almost done with everything. So let's try to draw the number. Part C of the same question. Part C. Part C. N, you said is 100. P, you said is 0.36. That is 36%. And then Q is 1 minus 0.36, which is 0.64. Okay, guys, are we together?
Yeah.
Okay. Just a second. I'm trying to respond to a call here. I'm sorry, just a minute. I just didn't switch off the phone. Okay. So, guys together, this guy wants the probability that what? Can someone help?
Hello. Kindly display the question.
No, but I don't mean a question bank.
Probability that the number of workers who belong to trade unions
1
will be
second,
from
dear.
24 to 20.
1 second, dear. Tukola November 2014, question 2 part C. Question 2 part C. Mbasaba mufune question bank. I know it's the last week. Now, yeah, you need a question bank, colleagues. Okay, let me share it here. Okay, so that it will be from 24 to 42. How do you write that? Probability that what?
Probability that 24 is it is less or equal to 42.
Less or equal to?
X.
X.
X. Uh-huh.
Less or equal to 42.
Wow, that's nice. What if he had said that will be between 24 and 42? How would it be?
Probability of 24 less X less 42.
Nice, nice. Hey, this makes me happy. Katia Wono, I feel you guys. Okay, so this is the thing. He's saying that it was from 24 to 42. Our X is here. Less or equal, less or equal. So we want probability that 24 is less or equal to X, less or equal to 42. Now, we would like to translate this to a normal distribution. What will a normal distribution read? So, if 24 is less or equal to X, it means X is greater or equal to 24. Are you with me? Monfuna?
Yes.
We've split this part to read this. Okay? So when X is greater or equal to 24, what will a normal distribution read?
X we less 0.5.
Mm-hmm. So X is greater than?
Or equal to 20.
No. In the
Mm.
normal distribution, you don't have greater or equal. It's just greater. Mm-hmm. It is the same.
X is greater.
Mm-hmm.
20, is it 23? Let me see. 24 minus 0 23.5.
23.5. Good job. And then this one is direct. X is less or equal to 42. The normal distribution will read
X is greater than 42.5.
X is less than X is less than
42.5.
X is less than 42.5. Because as you drop from 42.5, you must cross 42. So we shall therefore have 23. We want the probability that 23.5 is less than X less than 42.5. Okay? So can someone remind us that we shall need to standardize, right? We know that Z, recall.
Z equals X minus mu
Nice.
over
Standard deviation.
sigma.
Over sigma. Good job. Nice. So we need mu. Our mu we said is equal to NP. And this will be 100 times 0.36, okay? So our mu is equal to 36. Kindly stop us when you are not comfortable. Okay, we need sigma. Sigma is square root of NP Q. So this would be square root of what?
Square root of 100 times
100 times
0.36
times
0.64.
Good job. What do we get?
4.8.
Come again?
It's 4.8.
4 point?
4.8.
Net.
4.8 net.
Okay, perfect. Okay, nice. That was nice. So we are going to standardize each of them. We are calling this X1, calling that X2. So you are going to compute Z1, which is X1 minus mu over sigma. Our X1 is 23.5 minus 36 divided by 4.8. What do you get for Z1 to 2 decimal places?
Will be a negative 2.604.
Negative 2.604, so 0. Okay, and then Z2 would be 42.5 minus 36 divided by 4.8. To 2 decimal places, Z2 is equal to
1.35.
1.35. So we want probability that minus 2.60 is less than Z less than 1.35. Kindly, is there someone left behind? Is there someone feeling uncomfortable? Especially
Yes,
Manu fan?
I wanted to ask. Hello.
Yes, go ahead.
I wanted to ask, why is it that we remove those like the equal to when it comes to, I don't know.
For a normal distribution, okay? For a normal distribution, it doesn't matter. Z greater than 0.25 is the same as Z greater or equal to 0.25. The probability will be the same because it's continuous. You get what I mean? So for it does not use, when you use the inequality sign, that inequality sign also takes on the boundary. Okay, it is less or equal. Less or equal would be the same as less than, because it goes up to the boundary. I'm sorry, am I clear?
Yes, you are. Thank you.
Yeah, so whether you maintain the less or equal to under the normal distribution doesn't really matter. Okay? Okay, good job. Good job. Kindly stop us for those queries along the way. So we shall have our normal distribution curve where we have one figure in the negative, right? So we have Z1 equal to negative 2.6, and we have Z2 equal to 1.35. So these are the areas. We have area A, B, C, and D. Which area do they want?
They want B and C.
Good job. They want B and C. This one here, and then this one here. So we go to our normal distribution table and look for the area covered by 2.6. Remember, for a negative, you look for the positive. 2.6. So 2.6 is along here. I hope we can all see it. So 2.6 is the same as 2.60. You come all the way, and this connects here. Okay? That one we shall read 0.4953. 0.4953. And then for C, we look for 1.35. Panange mumfuna.
Yeah, we feel you never. Oh, yeah.
Mukoye. Mukoye nedda tetunaba kuko. Did you sing those songs? Let's not give up. We are almost there. You
Sorry,
people went to,
but not applicable here.
you people you people went to kindergarten. You didn't go to nursery, right? Okay. So we want 1.35. You look for 1.3 on the horizontal, and then come and pick the 5 on the vertical. You see that? So you read 0.4115. 0.4115. Okay, so the gentleman advised that we need area B and C. Are you going to add or subtract?
We add.
We add. So shall have 0.4953 plus 0.4115. And what do you get?
0.9068.
0.9608. So probability that it was from 24 to... Come again, brother?
0.9068.
Oh, 9068. Sorry, I'm just excited. 68. Okay. So
Excuse
this is 0.9068.
Excuse me, sir.
Yes, please.
I came across a number. Maybe you talked about it, but I've been traveling, so I couldn't pick everything to
Mhm.
you. But the number was okay. It was between 4 to 8. Yeah,
Mm.
and I was wondering that between my thinking was
Oh,
maybe like
between
from between 4 to 8
4 to
and 8. No, and 4 and sorry, 4 and 8.
between 4 and
8.
yes.
Yeah, and I don't know. Do we include the 4? Is it that thingy? 4 less or equal 4 greater or equal to no 4 less or equal to x, and then x
Can
less or
someone help
equal
us,
to
guys?
8 or something.
Can someone help us? Should we write probability of 4 is less or equal to x less or equal to 8? Or we write probability of 4 less than x less than 8? Can someone help?
So we write probability 4 less than x less than 8.
Thank you. So that means these are excluded. Is that okay?
Okay, but so in case we have anything like 2, that is when we include them.
Yes, from. Like he can tell you that between 4 and 8 inclusive. Now, between 4 and 8 inclusive, he only includes the last one because he said between. He didn't say from 4. So the inclusive includes only 8. Are you getting me?
Oh, yeah.
It's just the language and the little interpretation. I know you can do that.
Thank you so much.
Hello, are you there?
Excuse me, sir.
Yes, thank you.
Okay, is this clear? Does this make sense to you?
So it would
This
mean that means that it will be probability of 4 less than x less or equal to 8.
Yes.
Correct. Thank you.
So, excuse me.
Yes.
Does it mean that okay, if it's between 4 and 8, does it mean that it is a probability of 5, 6, and 7?
Yes, please. Yeah. 5, 6, and 7. Perfect.
Okay, thank you.
Okay. Now, guys, before I leave this, it's not always that we approximate. Where you are given a question and it's already a normal distribution, do not approximate. Like, for instance, the guy tells you the average pay in the company is known to be 400 USD with a standard deviation of maybe 12. Determine the probability that employees received maybe 428 USD. Do not try to stand or less than 428 USD. Do not try to approximate. This is already a binomial, a normal distribution. He has given the standard deviation and the average. They are already given. So there's nothing like approximation. Do you get what I mean, guys?
Yes, we do.
Okay.
Me, I don't.
So the mean has already been given and the standard deviation. He hasn't given you the n, neither has he given you the P. So these are already given. You don't need to standardize, to approximate. I hope God can help me get a question here. But before I go into that, I may forget what I want to talk about. Okay. People at one point were asking, when do I subtract 0.5? When do I add it? Okay, here we go. Let's first take Z2. We want where Z2 is equal to 1.35. Are you with me?
Yes, we are.
Yes.
So assume we wanted probability Z2 greater than 1.35. Okay? So I come to my normal distribution curve and I place it here. Follow my purple. Do you see it? Now, I have areas N and M. Which of those two areas does he want when he says greater than 1.35?
M.
M.
He wants M. But I already know N. Are we together? So our M will equal to what?
0.5 minus N.
Good job. Thank you. Now, if now we, that's a good one. If now we want probability Z2 less than 1.35, which area does he want?
ABN.
ABN.
Eh?
ABN.
He wants
A,
A, B, and N.
he wants area.
A, B, N.
A, he wants, thank you. He wants area A, B, and N. He wants N plus the entire area on the left. Okay? So what will that be?
0.5
0.5 plus 0.4115.
Good job. Thank you. Okay, so this is where we add or subtract. So the addition or subtracting depends on where your figure is. Okay, you have to look for that. Let's go on the left. Okay, where we have the negative.
Excuse me, Baz.
Please.
Can I use in case I wanted ABN? Can I use 1 minus minus the answer that I get when I calculate 0.5 minus 0.1, 0.4115?
Come again? I missed that.
Supposing I go to 1 minus this M after I've calculated the M.
Yeah.
Can it give me ABN?
Oh, yeah, it gives you ABN. Yeah, pretty much. Because the total area is 1. Perfect. Yeah, so just feel fluid when you are computing, as long as you can make your right interpretation. I don't have a problem. Okay, good one. Good one. Okay, now let's go to the negative side. Okay, I'll wrap this. You'll allow me. If on the negative side, we want probability Z Z1 greater than minus 2.6. Which area does he want?
B, C, D.
B, C, D. But B, C, D is everything at 0. What? 5. So tell us it will be
0.5 plus 0.4953.
Thank you. Okay. Now, if we wanted probability Z less than negative 2.6, what area does he want?
A.
He wants A. Okay?
Yeah.
Okay. Good job. That's all I wanted to, put right with you. Unless otherwise someone has a challenge, please let us know. Okay? I just wanted to do that side walking with you. Okay, nice. We've done the approximation. Now, very quickly, I would like to go to a question I shared with you, just to highlight, not necessarily to do it. Okay? The gentleman with the calculator, I think we did this already. Sent. But thank you for sharing. I've sent back. There is a question I shared that I would like to highlight with you very quickly. We are not necessarily going to do it. You guys will find time and try out. It's not really hard. We just want to look at the notation, how the guy writes. Okay. Yeah, Geno, right here. Right here. Can someone read for us part A? Question 3, part A.
Let me read.
Please.
Identify two conditions, that is A1.
Yeah.
Identify two conditions under which the binomial distribution, that is B into NP, can be approximated by a normal distribution.
Okay. Can we quickly do that? What are the conditions?
NP must be greater than greater
5.
A.
And then
NQ is greater than 5.
Greater than 5.
NPQ should be greater than 5. It is NPQ, not just NQ. Okay? Okay, good.
Excuse me, Buzz. Is it
Yeah.
greater than or equals to or greater than?
Greater or equal to.
Okay.
What about the sample size?
No. The sample size has it's not part of the condition. Yeah.
Okay.
Sample size being a condition is about whether you're going to use a t distribution or a normal distribution. Okay. When the size is small, less than 30, we use t. When the size is big or large, n greater or equal to 30, we use a normal distribution. Okay?
Thank you.
Okay, good.
Excuse me, sir.
Please go on. The lady who was reading.
Excuse me.
Okay.
Yes,
we
please.
got
Go ahead.
two.
Sorry, just a second. There's a gentleman asking. Yes?
Yes, sir. Does it mean these two conditions must be fulfilled? What if one is fulfilled and another is not?
Then you cannot approximate. You leave it as a binomial distribution. Yes.
Okay, thank you.
You're welcome. Okay, please go ahead.
Okay, we go to 3A2. A random variable, x, has the binomial distribution b into brackets 25 and then 0.38 close brackets. Required. Prove that the distribution can be approximated by a normal distribution.
Okay. What is the proof?
Proof NP.
We calculate the NP and then NPQ.
Okay, let's try. So in this case, what is our P?
0.38.
0.38. And our N is?
25.
25.
25. So we test NP. NP is 25 times 0.38. What do you get?
9.5.
9.5. So already this is greater than 5. Now we check NPQ. NPQ would be 25 times 0.38 times what?
0.62.
Our Q is 1 minus 0.38. So she said 0.62. What do you get?
5.89.
89.
5.89. And this is greater than 5. So we have shown, because these two conditions have been fulfilled, hence we can approximate.
Binomial.
Good. Okay. Perfect. Please go to part 3. The lady.
Okay. Question 3A3. Use the normal approximation to binomial to calculate the probability that x takes a value more than 15.
Okay. Probability x more than 15. What's the symbol?
Greater than 15.
Greater than
15.
Yeah.
X, probability of x is
greater than 15. Okay. When we approximate, what will x read?
Greater 15.5.
15.5. So this is what you are going to put in the normal distribution. Any queries, guys, about approximation? So here, this is where you'll apply z equal to x minus mu over sigma, and then you proceed.
Excuse me, sir.
Yes, please.
Yeah, I think my network was off. Did you say that the properties of binomial distribution are those two, only two? The NP greater or equal to 5 and the NPQ. Are those the only properties?
The conditions.
Rather, conditions.
Excuse me, sir.
Yeah.
Those two, eh?
Yeah, those are only.
Okay.
Hello. Why do we have x greater than 15.5, not 14.5? Since the sign is greater.
For greater, we add. If it is greater or equal to, that is when we subtract.
Oh, yeah. Oh, okay. Okay. Thank you. So also, if it is less alone, we less.
Yeah, less alone, we less or equal to, we add.
Greater you add, less you less.
Pardon me,
But
guys.
if you have
I
anything
temporarily
equal
went
to,
off.
we add. We do the reverse.
Okay. Sorry, bana munsonyi when navuddeko. I temporarily went off. But otherwise we are back. I don't know if there was a question we were trying to answer.
Tubadde tufunye tuto mpya.
Oh, nice. Nice. Mukyala oba mwami?
Abadde mukyala, she did good.
Era okale. Era okale. Okay, guys together. That's nice. That's nice. I don't know which conversation I stopped, but it should continue. Had she finished explaining?
She was still explaining. Tutor, go ahead.
Diane,
Yeah, you go.
Tusimbudde dda tuli mu Tuesday kati.
You know?
Okay, guys, I hope it's all good. Now, let's go to a Poisson. In here, with what we were doing, we've been able to look at a normal distribution also, how to determine the probabilities of a normal distribution. This guy may tell you, actually, before I forget, when you look at one of our examples in class, this guy may tell you, check purple. He may tell you that if there were so here there were 7,000 workers, right? So determine okay, here it was already determined, but let's assume it's a pay. Okay, let's assume these probabilities were about pay, and the guy is asking us to determine the number of workers that received from 24 to 42 USDs. So you need to determine the probability that a worker will receive 24 to 42. Okay? Now, that probability, assume it is determine the number of workers that will receive between that if the company had, let's say, 8,000 workers. So we need the probability of receiving from 24 to 42, which was 0.9068. Now, expected number will be that times the 8,000. Is that okay? Are we clear, guys?
Yeah, it is. It is very clear.
Okay, perfect. Guys, together. What did I want to talk about? The Poisson distribution.
Sir.
Yes, please.
More light on x is equal to 60.
X is equal to?
To 60. How you treat it.
Oh, how we treated it. Okay, take it from this, actually, for a quicker understanding or to quickly appreciate it. Let's do a sidewalk here. For x equal to 60, okay, just know that a figure can be overstated or understated. So when someone tells you x is equal to 60, it is a plus or minus 0.5. In other words, if it is understated, it will be a minus. So it will be 60 minus 0.5 to have 59.5. If it is overstated, it will be 60 plus 0.5, which is 60.5. In other words, your x value is ranging from 59.5 to 60.5. Brother, does it make sense to you? Does that little explanation make sense?
Yes, sir.
Yeah. So for equality, you go by plus or minus that figure they have given you, whereby the lower figure will be when you've subtracted a 0.5, and the upper figure will be when you have added.
Thank you very much, sir. I appreciate
You're welcome. Thanks for that question. Okay. So for the Poisson distribution, we are saying that this is a discrete that uses the average occurrences. Okay? Usually, the number of occurrences n is large. Okay, i.e. n greater or equal to 30, but likelihood of occurrence for a given event is small, i.e. probability of x less or equal to 0.5%. Okay, usually. So how do I tell I have a Poisson distribution? The examiner will mention, or even with yourself, you should be able to tell. When the guy uses average number of occurrences, just know I'm dealing with a Poisson. Okay? So given a Poisson situation, the probability of a random event x shall be given by probability x is equal to e power minus lambda times lambda power x over x factorial. So where lambda is equal to average occurrences, and then x is equal to number of successes. Call them the desired occurrences. And then E is the exponential value. You don't need to know it, you know. Okay. Oh, maybe guys, on another note, if you are sending me private work, like stuff you've done privately, like a message, please use my MTN. I've seen where I'm taking some bit of time to respond to people, even when they see me online. So it's like seeing me online and I'm not responding to your work. Usually the questions I share them through my tablet, and I know it's where you've sent your work, but I do not really check because this tablet is, how do I call it? I use it mainly to share work, if I can say that. But for me to review your work, I prefer using the phone. So that's why I take some time really to respond to people's work. Please, you pardon me. You pardon me on that. Okay. So we are going to look for a question here and then try out. Okay? Try out. I don't know if people have any numbers, but among those that I shared, does someone feel like sharing one? Let's see. Yeah. We pick a question to do. Yeah, something like this. Okay, now I want to explain something with this question. You realize that the likelihood of occurrence is big. It's bigger than 5%. Okay? But then the sample size or the likelihood of an occurrence is small. So it compensates the smaller probability in the number of occurrences. So the occurrences were small, but the probability, the chances were bigger. Okay, maybe before that, mean of a Poisson distribution. So this is given by lambda is equal to NP. And by the way, even for variance of a Poisson, it is the same. Yeah, sigma squared is also NP. So for a Poisson, the mean and the variance are the same. Okay, so we take an example here. Our example is from August 2017. August 2017. Which question is that? I didn't take the question number. August 2017.
Question 3.
Question 3, you said. Okay, question 3. Okay. May someone read for us, please?
At Nansana Brick Factory, 10% of the bricks produced are found defective. A sample of 15 bricks was chosen at random from the factory. Required: use the Poisson probability distribution to compute the probability that in the sample 1, exactly 2 bricks are defective, 2, more than 1 brick are defective.
Okay. So part 1, guys, I guess you have the question. So we are doing part C, part 1. They want probability that X is what?
Exact. X equals 2.
X is equal to?
2.
To 2. Okay. So we know that probability of X will equal to e power minus lambda times lambda to the X over X factorial. So probability X equal to 2 will be e power minus. Now, we don't have the lambda. We need to find it, right? So lambda is equal to NP. What was your N?
15.
15. And your P was?
0.1.
0.1. Okay, so therefore lambda would be 15 times 0.1. To have what? 1.5. So now probability X equal to 2 would be e power minus 1.5 times 1.5 power 2 over 2 factorial. Can you give us an answer to 4 decimal places? So we are going to press on your calculator. You have a button with natural log. On top of it, there is an EX. So to get the EX, we are going to press Shift, and then you press the in button. A little E will show on your screen. Do you see it?
Yes.
Okay. You open a bracket and say negative 1.5, close it, times 1.5 to power 2. And then divided by 2, Shift. Remember the factorial symbol? It's at x power negative 1. That's why you have x factorial. Okay? What do you get to 4 decimal places?
0.251 0.
0.251, 0.251. So probability x equal to 2 was 0.251. Okay, any queries, guys? Okay, that more than one brick are defective. More than one brick are defective. Part 2. Probability
Of X.
more than 1.
Yes.
This is the same as probability x is what?
X is greater than 1.
X is greater than 1. Okay, so probability x greater than 1 is the same as what? Probability of
X less than 1 plus
1 minus probability of x less than 1.
Okay, good job. But let's first show this. It would be 2 or 3. That's nice. Or 4 or up to infinity. Now, you cannot move all the way to that. Under a Poisson, guys, listen.
Yes.
Assume our average. The what? The what? Yeah, I got it. Said what? 0.9 is big enough, so it's okay.
0.9.
Yeah, it's big enough. I'll be done by that time. We're all good. Okay. Sorry, guys. Assume, guys, our average was, let's say, assume our average, let's say, I'm just giving an example, was, let's say, up to 4. Okay? Assume we computed an average and we got 4 bricks. Are you with me? This will still go beyond 4 because that average is not an exact number. Are we together? The moment it's a Poisson distribution and it is greater than, it goes up to infinity. So what do you do? There's something someone was telling us. Can you say it again, please? So probability x greater than 1 is the same as?
probability
1
x
minus probability x less than 1.
less than 1.
Probability 1 minus probability x less than or less or equal to 1, because this is greater than 1. Okay, so we should have the greater or equal, i.e. this is from
So we change the sign.
probability x greater than 1 plus probability x less or equal to 1, less or equal to 1 should equal to 1, the total probability. Okay, that's where it's coming from, because you cannot compute probability from 2 up to infinity. Okay, so that's how you go about it.
Excuse me, Sir Francis.
Yes, sir.
For me, I thought I would get a probability of 0 and of 0 only because they are saying more than 1. Then I erase it from 1. The whole sum of probability.
More than 1, what you are leaving is a 1 and a 0, not only 0. You get it?
More than 1 starts from 2.
Thank you. More than 1 starts from 2. Thank you for that. I think that's a better explanation. It's right here. More than 1 starts from 2. You got it?
Thank you.
You're welcome.
Yeah.
Excuse me, Baz.
Yes, please.
What if 1 was inclusive? How would it be stated like?
Oh, the
Yeah.
probability that at least one brick, okay, is defective.
At least is the main word.
Yeah. At least would mean greater or equal to 1. Yeah, sure.
And at most?
At most, that is the highest you can go. So at most would be 1 and below.
Yeah.
Okay. Thank you.
Good. Oh, by the way, those are nice words. Let's just summarize them quickly here. So at most 1, we are saying probability x less or equal to 1. At least 1, we want probability x greater or equal to 1. Thank you for that. Okay, so we need to look for probability x less or equal to 1 as what? Probability of?
Probability of less or equal to 1 is 0 and 1.
Thank you. 0 or 1. So it will be probability of 0 plus probability of 1. So probability r equal to 0 will equal to e power minus 1.5 times 1.5 power 0 over 0 factorial. And probability r equal to 1 would be e power minus 1.5 power 1 over 1 factorial. I'm sorry, guys, but are we together? I hope I'm not leaving anyone behind. Okay,
So
can
far,
you give
so
us
good.
those 6 to 4 decimal places? Yes? Oh, so far so good. Okay.
Yeah.
Francis, what time is the discussion ending? Okay, it will end. We are about. Okay.
We still have Kendall.
The first one is 0.223.
Yes, Kendall.
0 point.
Hey guys.
Hey,
2.
Baz, anything can wait, but not Penda.
Yes, talk about
0.22 what?
3-1. Or you can just end at 3.
Okay, we keep that. And then this will be 0 point.
334.
334.
6.
6. Okay, so we need to sum up this. What do you get? 0.557 what? 77.
7.
Okay, so probability x greater than 1 will be 1 minus 0.5577. And what do you get?
One.
0.4423.
Yeah.
0.4423. So probability x greater than 1 would be 0.442. Any queries? Okay. Quickly, we close that. So you've seen a binomial and a Poisson. Let me check something here. Quickly. Of what I'd wanted you to see. Right here. You remember someone asked us a question that what if the examiner has not specified whether I should approximate or not? What do I do? Are we together?
Yeah.
Okay. And then in this same question, there's something I'd like you to see, the definition of a success. So in the first one here, in this question, two things were tested. Okay. So can someone read the first part? We're not going to do it, but just to explain.
Of part of B,
Part B, yes.
the Communications Commission, in their annual report on consumption of mobile network services, indicated that mobile company Z had 35% of their clients using the mobile money service. If 12 customers are randomly picked from one of their sales points required, find the probability that Roman 1, exactly 4 customers, Roman 2, between 4 and 8 customers transacted on mobile money.
Okay, good. Right there. You'll read part C later. The question is, are you going to use a binomial distribution or a Poisson? First of all, on that, will it be binomial or Poisson? Can someone help us?
Poisson.
I think Poisson, Roman 1.
Why Poisson?
Yeah, I would go with binomial.
Okay. Why Poisson? Why binomial?
Why binomial is because we have the probability of a success, which is 35% of people using mobile money.
Okay. And also, what else do you have?
Also have N, which is 12 customers.
Guys, are we at par?
Get Q.
Now, also under the Poisson, these can be given. But for a Poisson, this here, one of them, like this one here, may be very big, and this is small. And then it can happen that this is big, and this is small. So someone will tell you, for both a Poisson and a binomial, they would both pass. Because for a Poisson, you can compute NP. Monfona.
Yes.
And you determine the average number. When you try out, the answers will be close.
The NP
Because
will
they
be
did not.
35% out. 35% times 12.
Yes. So you get the lambda for a Poisson. Okay. And then your X here will be 4. You compute for it. Okay. And then for between, you'll compute 5, 6, and 7. Either for a Poisson or a binomial. Are you getting me, guys? Your answers are going to be close. Okay? So because they didn't specify. So that one is okay.
So you
someone-
mean to say that whatever you use is okay if
long
they
as
Okay.
did specify?
Yeah, if they have not specified, the binomial and the Poisson would pass. But where the binomial fails is if n is very big here, you won't use the binomial. Okay?
Yeah.
You'll instead need to approximate it. I'm coming to that, whereby visual, you are able to tell that I'll approximate. Now, my advice on this, since the n is relatively small and p is large, you go for a binomial distribution. Okay? You'd go for a binomial distribution. Now, the other question would be, am I going to approximate or not? Okay? You test. What is your n? NP.
NP is 4.2.
Okay, so it will be 12 times 0.35. So you get 4.2. It means that I cannot approximate it to a normal distribution because one of the conditions has not been respected. So hence I'll use the binomial distribution directly as is. Okay, I intended to spend a short time on this. Let's go to the next thing. That part C is my major concern. Okay, part C.
A
Can you
car
read it?
dealer, a car dealer in Gingertown has established that 52% of the cars he sells have no defects. The last batch of cars that he sold was 150. Required, find the probability that at least 75 cars had defects.
Okay, so in this question, what is our P?
Probability of a success P. It's 0.48 because the question
Has no defects.
hello.
Yeah, go ahead.
The question wants us to handle those that had defects, and
People, are you listening? Okay, go ahead.
the question wants us to look out for the probability of those that had defects, but the 52% given was for those that had no defects. So that makes us
the success.
Look out for the like 100% minus 2%, and the 0.48 will be the probability for a success.
Thank you very much. I cannot add anything on that. Okay, she's really put it out. If you remember what we said that a success is defined by what the question is asking. The question is asking for those that had defects. But what he has given in the statement is a probability of those without defects. That means the probability they gave was for a failure. Okay, he gave UQ.
Okay, 52.
Okay, perfect. Thank you. Now, our next is, am I going to approximate or not? Okay? Before you even test the, come again? What did you
Yes, you
say?
are going to approximate.
You're going to approximate. Okay, now, before you even think of it, or whether it is possible or not, when he says, what is your N here?
150.
150. So the guy is saying probability that at least that is X is greater or equal to 75, not so. So this one you need probability of 75 or
greater.
75 or
50.
Or 70 what? Greater or equal?
76.
76 or up to
150.
Thank you. I cannot compute these figures from 75 to 150. It is going to take me a lot of time. Even if I was going to use the reverse, that probability x greater or equal to 75 is the same as 1 minus probability x less than 75. You see that? I'll still compute from 0 up to 74. That is big again. So the best way is to test whether I can approximate. We are looking at a scenario where without a mention, I should either approximate or not. Are you with me? Okay. So someone said we should. Why did you say we should?
Because our NP will be greater than 5. It will
Good
be
job.
0.48 times 150, which is 72.
And our NPQ would be 0.48 times 150 times 0.52. Okay, so you can approximate. Okay, that the last batch was okay. So at least we want probability that x is what?
75.
Come again.
At least. Oh, less. Sorry, greater.
Greater or equal to.
Greater or equal to 75.
Okay, what will the normal distribution read for greater or equal to 75?
Probability
is greater than
74.5.
Greater than?
75.5.
74.5.
74.5. Okay. Remember, you are coming from a lower and ascending. So as you ascend, you must cross 75. Okay. Good job.
Maybe those ones, we just cram them.
No. You don't need to cram. For instance, if I told you that x is greater than 50, it means under the normal distribution, x greater than 50 will read what? X must be greater than 50. So I have a plus or minus 0.5. If it is greater, then x must be greater than what?
50. Must be greater than 49.5.
50.5. We are talking of greater. In other
When you say
words,
49.5, it means you're including the 50, yet we do not want to meet a 50 anywhere.
Thank you. As you increase the x, you've really said it well. That when you say 49.5, it means that as you increase, because it's a greater than, x is greater than that, is greater than 50. As you move to infinity, you're going to cross a 50, which shouldn't be there because you've been told x is greater than 50.
50.
So if we wrote x greater than 49.5, as we move from 49.5, we are going to be increasing the figures. It will come to a 50, yet we've been told it should be greater than 50. So when we put it at 50.5, we shall never cross 50. Make sense?
Yeah,
That all is a thought. Okay, good. Nice. Okay. So guys, I wanted you to, yes.
For instance, if someone is approximating you said x is greater than 50, and then someone again on the approximation forgets to put no, you first go back on the other page while you were writing, then I can ask very well.
We want x.
Okay, if someone is approximating,
yes,
and then instead of putting a greater or equal sign, they still keep the greater sign only. Does that still make
So
sense when they are
let's
doing
say
the normal distribution?
x greater than 50.
Yes.
Okay. And this will be
And then in
x
approximation,
greater than
they put
50.5.
yes, 50.5. Does it still keep right when we are doing the normal distribution? Does
When I
that change the
approximate and
answer?
say what?
Or when you approximate and on approximation, for example, someone puts x is greater or equal to 50.5, does it still make sense? Does it change
Yeah.
anything?
Okay. To the examiner's notation, let's say I wrote x greater or equal, we needed x greater or equal to 50, and then on approximation we say x shall be greater or equal to 49.5. Not so? Isn't that what you're talking about?
Yes.
That have included an equal instead of saying x is greater than 49.5. I guess that's what you're asking.
Yes.
Yeah, on a normal distribution, these are the same. The probability will be the same, sure.
Oh, okay, thank you.
So you won't have any problem. Yeah.
All right, thank you so much.
Okay, good. Okay, so guys, I want to invite you to confidence interval very quickly. I guess I shared a question about it. Confidence interval for a normal distribution. This one here, the number of injuries, blah, blah, blah. You see this? You see how big this is? This one here. And then the probability is here very small, okay, that someone gets an injury. Now, please watch out. When the examiner writes 0.1%, people feel it is too small for you even to continue dividing by 100. Please go ahead and say 0.1 out of 100, which is 0.001. I saw it in the mock. You messed up. You were taking 0.1 because you felt the percentage was small. You go ahead and do that, okay? So there you go, one of those questions. If you tried it with a binomial, you'd see what you get, okay? You find the mean and then you can apply the binomial, but your n is really big, if you can look at that, okay? Your n is really big. Okay, of course you cannot approximate because the mean would be very small, okay? I was heading to this. I think is that one. Okay, that's okay, this one here. Did someone try it out? This one. Did someone try it out? Okay, my 2018. And that is question 3. My 2018 question 3. May someone read it for us? We do confidence interval for a normal distribution.
A busy restaurant in the center of artisan workshops in Kampala buys fruits in bags towards festive seasons. In order to ensure the quantity of the fruits packed in the bags were accurate, a sample of 360 bags was tested and it yielded a mean weight of 100 kgs and standard deviation of 15 kgs. required, estimate the 99% confidence interval of the mean weight of all the
I think
bags
she went
bought
off.
by the merchant.
Did she?
She's still on.
Hello.
Guys, are you
She's on.
there?
Yes, we are there.
She's on. It's you who has gone off, maybe.
We are on. Nazze kuketta.
Hola. Diablo. Holo vitu komesa fusi. Wawulira da. Ajemeyo hatono gole.
Hello, maybe
Chinja
as
ofi.
the person who wanted some highlights about Kendall, is she still here?
Yeah, I'm here.
Okay.
There
Yeah.
was some other lady, I don't know, but
kubanga.
So for Kendall, like we know we have two methods, like the methods of rank correlation. Yeah. One we have Spearman, of which he said in an exam, if at all they don't specify to either use Kendall or Spearman, we use Spearman correlation. Yeah.
If they
But
don't
when they
specify totally, we use Spearman.
Yeah. Yes, if they don't specify at all. He had
Okay.
mentioned that in class. Yeah. We use Spearmans because it's the mostly used one. So there are two categories. We have Spearmans and then Kendall. So for Kendall, Kendall, here we have two terms to put our focus on. We have the concordant and the discordant.
The concordant and the discordant.
It's back. So
Okay. Thank you. I was trying to listen. It's a nice discussion. I thought like leaving out the confidence interval. I feel you guys can do it unless otherwise. I I don't know which
No, sir.
hypothesis you
No,
would
sir.
like us. Come
Let's
again?
do it. Let's do it.
Oh, okay. Okay. My 2018, my bad. Confidence interval for the mean. We are saying that this is given by mu is equal to x bar plus or minus z times s over root n. But we said something. You may be given sigma, okay? Sigma may be given. Okay. So where mu is equal to the population mean, x bar is sample mean. S is sample standard deviation, or sigma, which is the population standard deviation. N is sample size. Okay. So guys, this is it. When you are given a level of confidence, this is what it means. When they give you a confidence level, they have given you this area, this percentage, confidence interval.
29%.
In hypothesis text testing, we call it the acceptance area. So it's bordered by a Z1 and a Z2. Listen, whenever they give you a confidence interval, they want you to find Z1 and Z2. Okay? So you will come through under our example. Our example is a my 2018 question 3.2. Question 3A, part 2. Okay? We are saying, what do we have? Let me see here. Yeah, nachira nange tekiri wala. Let me get it from my papers. My 2018. Okay. So what do you see in this question? Can someone read for us?
The entire
Part
a
2.
busy restaurant in the center of artisan workshops in Kampala buys fruits in bags towards festive seasons. In order to ensure the quantity of the fruits packed in the bags were accurate, a sample of 360 bags was tested and it yielded a mean weight of 100 kg and standard deviation of 15 kgs. Required. Estimate the 99% confidence interval of the mean weight of all the bags bought by the restaurant.
Okay. Guys, can you tell us what you see? What do you see?
There is
N,
SD.
but I see N 360.
Okay, so they want the mean weight for all the bags.
No, we have the mean weight.
Okay.
No, problem is even
So you have N. You said N is what?
360.
Mm-hmm.
You removed the question. Then we have X bar.
Oh,
Mean
sorry. I
weight
shared
over
it in WhatsApp. X bar is
100.
100.
S is 15.
Mm-hmm. S is
15.
15. Okay. So what else has been given?
Standard deviation.
Mm-hmm. Standard deviation, we picked it.
The level of significance.
Yes.
Come
Significance.
again.
Confidence interval.
Level of significance. The 99, I think it was 199.
What's 99?
99 confidence interval.
Confidence level, okay? Because it's a percentage. So the confidence level is 99%. If I may ask, in the formula, what don't we have?
Z.
The Z.
Good. We don't have the Z. But the moment they give us the confidence level, we can generate the Z. How? So you come to your normal distribution curve.
Because when do we draw a bigger chibel and a smaller one?
Which bigger one?
This hill is big.
Oh, it is steeper. It's under T. Mm-hmm.
Distribution. Sati distribution.
Mm-hmm.
Okay.
Good. So in the middle, we have 99%. You have a Z1 and a Z2. When you split 99, what will you have?
49.5.
49.5% and 49.5%, which is 0.495, 0.495. What's the Z value?
Value will be 2.57.
2.5, 2.57.
2.575, 2.575. I guess, guys, currently you're good at that. Unless otherwise someone needs help, we can do it. Okay. So shall have mu equal to our X bar was
100.
100 plus or minus what?
Plus or minus 2.575, 2.575.
Times S, our S is
15.
15 divided by the
By
square root of
360.
360. Good job. So this stops here, okay? It is the division stops within after the plus or minus. Doesn't capture the 100. So we shall have 100 plus or minus what? Two decimal places.
$2.046.
2.035.
2.035. So our mu is 100 plus or minus 2.035. So mu1 is when it's a minus, right? 100 minus 2.035. What do you get?
97.96.
0.96. And then mu2 is when it's a plus. So mu2 is
102.03.
102.03. Now, you realize that actually this question stops here. This is what they wanted. Okay? That plus or minus. That's the interval. So we shall get here, and if we are asked for a comment, that's when we go ahead to get mu1 and mu2. And we shall say that we are
We are 99% confident.
We are 99%
confident that
confident or sure that
dash lies between I think so. I need to call the wording. Yes, the wording. I have no question.
Okay, we are 99% sure that the population mean or average lies
between 97.96
and
102.03.
Okay, guys, I hope that is clear. Now, I also shared the confidence interval for proportions. Confidence interval for proportions. The treatment is the same, only that in one you are having a proportion. We said it is given by, who remembers? Phi is equal to?
Is it P bar, then Q bar? P bar
Is equal to
times
P plus or minus Z times P
Q out of N.
PQ out of N, everything to the what?
to the square root. Yes.
Okay, perfect. So katujua tunaonye number. I shared the question already.
Numbers.
Yes, please.
If I may ask, to what
Please do.
extent can they give us the formulas of probability in the on the formula sheet?
To a great extent, actually, lately. They give over 43 formulas. So
okay.
Thank
you.
To a great extent. But usually I invite you to practice them so that when a formula is given, you don't really struggle with the characters. Definition of characters, yeah.
But as long as
Okay.
we can't fail to figure out. Problem is not being given. Problem is with not being given one.
Okay, can someone some formulas are derived from the rest. Like for instance, he may give you a confidence interval for a t-distribution or for a normal distribution, and then they're asking for confidence interval of a t. That way you can determine using that same formula. Okay? It's the T that changes. Okay. Can someone try to read for us?
A random sample of 400 fruit juice drinkers revealed that 37% consume passion juice regularly. Find our 95% confidence limits for the proportion of fruit drinkers who regularly consume passion fruit.
Okay, good. Can people help us? What do they see?
And 400.
N as 400. What else?
The confidence level.
Confidence level, which is?
95%.
95%. What else?
As if I saw ICP. As if.
P, as if.
0.37.
37%. 0.37. Ngamuzogera muzitia.
Anti katumiza sanga ng'otomedde.
Tewakyali kutomera. Gwe batomera. Okay. So we are doing, I forget the question number. Example. Of course, on the sidewalk here, P is the sample proportion. And then N is equal to sample size. And Q is 1 minus P. Okay. Phi is the population proportion.
This formula is hard.
But you'll get it. It doesn't really. It's not so hard to grasp it. Okay, good. So our example was from which year? I didn't pick it.
November 2023.
November 2023. Do I have the paper here? Right, 2023. And this is question 3, part C. So this is question 3, part C. You said N was 400. P was 37%. And then confidence level was 95%. So we need the Z value at 95% because phi, the population proportion, is P plus or minus Z times PQ over N to the root. Okay, guys, tell me, we need the Z value at 95.
$475. Where is it?
Okay, so this is 95%. Split it, you said 47.5%, which is 0.475. Is there someone challenged with these values, reading them?
For the X, for the Z.
The Z value, yeah. Okay, we seem to be okay. Okay.
1.96.
You have 1.96 minus 1.96. This is 0 here.
The 1.96.
You got the same?
Yes.
How to read it?
How to read it? So we go to the tables.
and look at those values, both those many ones, and look for 0.4.
Those many ones. I like
you
those
read
explanations. Okay, the many ones
line.
is referring to where you see the figures in 4 decimal places. That's why she calls them many ones, because they are tiny figures. Okay? Obunjovo. So 0.475 is this figure. Now you need its address. It is in this row, 1.96, and the column is 6. That's why she's reading it as 1.96.
Noted. Thank you very much.
Good job. Good job. Okay.
Excuse me.
So what? Yes, sir.
Before you leave, how about if the figure is say 1.7954? You have a 3 decimal.
A 3 decimal for what?
You add.
What do you add? For example, you have 1.965
as what?
As your Z value.
Yes.
Your confidence interval is meaning
Yes.
when the addition of value is more than 3.
No, you round off. You round off.
So okay. You cannot
Like
read that.
Yes, continue.
I wanted to know if I can read from the table a value that is to 3 decimal place.
Oh, Z equal to 1.625.
Yes.
Okay, let me exemplify it here, but you'd be okay taking 1.63. It would also be okay, but let me show it here. Okay, I just used to encourage students to use 2. So if Z is 1.625, you come to 1.6 and then 2. You'll have that figure. But it is 1.625. You go to this, you see this where you see add?
Yeah.
That, and pick the 5. The 5 is here. You follow through and it crosses up to there. So to this figure here, you are going to add 0.0005 because those figures there are to 5 decimal places.
Okay.
Is that okay? Yeah.
Yeah.
But I encourage to maintain sorry, those figures are 4 decimal places, much as I'm saying 5. Yeah, I wrote 0.005. Okay. So you can always maintain 2 decimal places, okay? For the Z value. That is fine.
Excuse me, Baz.
Yes, please.
I think the person who asked how to get the value, the Z value, maybe you could also explain to that person how about when the value is in between 2 figures, how do they get it? This one is direct, but the question that they may bring in the paper or the question you will read next will need a figure that is in between the 2 values. How will he come up with that value?
Yeah, true. It is one of the previous values we actually had. This one here, 0.4, 0.495. So we come and look for 0.495 in our table. I'll use that. 0.495. 0.495 is a figure between 0.4949 and 0.4951. So this figure here has a Z value, and this one here has a Z value. The z-value here is 2.57 and the next is 2.58. So 2.57 and 2.58. We add these two and get an average, which comes to plus or minus 2.57. 5. Okay.
Yes, thank you very
I hope
much.
he has got it.
Does
Yes,
it
yes,
make sense, guys? Because the
yes.
figure you are looking for is between these two. Okay, when you add 0.4949 plus 0.4951 and divide by 2, you'll get 0.495. That means its corresponding area can also be got by adding and dividing by 2. Okay? Does it make sense, Sarah?
Yes, sir.
Yes. Thank you so much.
Okay, good. So let's come back here. You people don't get tired.
Oh yeah.
The coffee one.
Oh guys.
Okay. Okay, so our P was 0.37 plus or minus the Z, which is 1.96 times 0.37 times, what did you say our peak, our Q was?
0.63.
0.63. This is divided by N. What is this N?
400.
400. We put a bracket on this and get a root. Okay. So this would be 0.37 plus or minus. Now, guys, I want you to watch out. Actually, work out this first. Type square root, then open a bracket and have 0.37 times 0.63 divided by 400. That figure you get, you multiply it with 1.96.
Baz, gotokoye.
Sorry? We are closing. We are about to close.
0.047.
0.047. Nice. Okay, this is what they wanted. You'd be good if you left it like this. Unless otherwise they ask you for a comment. Okay? The comment will look similar to what we did up there.
I wanted to inquire whether we get two values, the plus or minus one. But
Yeah,
if we
we
leave it
do.
like that.
If you left it like this, you are good. You compute those two values when this guy asks you for a comment.
Okay.
And I think he had asked us to determine the upper and the lower, right? Didn't he? Find the confidence limits, not the confidence interval. So the first limit is phi 1 equal to 0.37 minus 0.047. What do you get?
$0.323.
0.323, and then phi 2, 0.37 plus 0.047. So phi 2 is equal to
0.417.
0.417. Okay, so you can comment and say that we are 95% sure that The
Why are we?
population.
What happens when we are not sure?
That the population, I'm going to explain. That's a good one, that the population proportion is between
Because actually, we want to be sure.
0.3 and 0.417. So what happens when we are not sure? So we shall be at 5% level of uncertainty. So we are 5% unsure. Okay. We are 5% sure. We are 5% sure that the population proportion does not lie. Okay, between 0.323 and 0.417. The other 5% is a level of rejection. Okay, it's a level of uncertainty.
So
Am I
if we
clear?
get one negative and the other is a positive, are we still sure?
Yeah, we are still sure that it lies in that area. You see, that value that you get is a table figure, which you are getting from your graph. Okay. Okay, guys, I don't know if I should leave you to do the hypothesis testing, and I
Yes.
quickly run into Kendall. Okay, but you need to do the hypothesis testing and share. Okay, because I'm going to be sharing some more questions later on, which I'll be attempting online. Okay, so let me quickly look at Kendall as you guys finish the other questions, mainly for hypothesis testing. I don't know how you'll do it, but let's try to close in. I'll explain Kendall. Okay, what was the issue?
The
Oh,
concordant and the
Mhm.
discordant.
I can explain that one in a few minutes.
You can?
Yes.
Okay, let's take an example and then you are going to help us appreciate it. Okay, this is correlation.
It's almost midnight.
Yeah, let's close in. Let's close in.
We are here till morning.
Hey, you are alone.
Okay. At a particular event, the age and the weights of participants were noted as shown. So we have the age in years and the weight. We're just taking an example in kg. Okay, so the age we had maybe 20 years, 25, 30, 28, 42, then 36. The weights were 60, 75, maybe 68, maybe 82, maybe 66, and 70. Okay, so the question is determine the correlation coefficient using Kendall's rank correlation or using Kendall's ranking. Okay, so when we recall we know that Kendall's ranking is equal to
Summation C
C.
minus summation D.
Okay, summation C minus summation D
Divided by summation D.
Over summation
C
plus summation D.
Okay. So now we are going to come in here and have the edge, have the weight, and then we shall have rank edge,
rank weight C,
rank
D.
weight, and then C and D. You're going to help us do it. We shall follow you. Okay. That person that said you will be helping.
I hope I don't give you poison, but okay.
It's okay. It kills us all. You inclusive.
Don't give us poison to Yam because we've been waiting for this.
I can't.
I know she won't. She must be good at it. Okay, 25. This is 30. 28. 42. And then 36. Our colleagues, once again, I teach at Capital College. That's where we are located. That's where you can find me.
You also studied at Capital College.
I also studied at Capital College. Yeah, that's nice. I study people, and yeah, it's a good one. Okay, so the weight, we tag them the way they are: 60, 75, 68, 82, 66,
70.
and 70. Okay, can you help us rank? We rank age.
I think it's better we start from like people understanding concordant and whatever that one. I don't know how to pronounce them. I don't know whether it's a challenge.
Would you appreciate if you went column by column so you can come to this later on, if you don't mind?
Yeah.
You first rank. Okay. Mm-hmm.
Okay. As far as I understand, Kendall, there are steps. There is a process that we follow. Yeah.
Okay.
And the process, number one, requires us to rank all the variables either from ascending or descending order. So the variables in question currently are age and weight. So we can rank these on the side in either ascending or descending order. Now, like for example, under age, we have 20 as the lowest, so we can give it a 1.
Mm-hmm.
We have 25 as the next one, we can give it a 2.
Mm-hmm.
8, a 3. We have 30, a 4. We have 36, a 5.
Mm-hmm.
And then 42, a 6.
Mm-hmm.
We do for weight. We have 60 as the first one, has a 1.
Mm-hmm.
We have 66, 2 as the second one. We have 68, the third one.
Mm-hmm.
We have 70, the fourth one.
Mm-hmm.
75, the fifth one.
Mm-hmm.
82 as the sixth one. So that's the very first step that we do. Step number 2 is capture one of the variable ranks in an ascending order. And then we match the rank to the corresponding rank. So in this case, we are going to capture.
Excuse me, tutor.
Yes.
Excuse me.
Yes.
On ranking weights, are we using descending or ascending?
Ascending. The same thing you used for age is what you use for weight.
Okay, thank you.
Okay, one thing I've noted is here we've started ranking from the smallest, but when you go to Spearman's, you start ranking from the highest to the lowest, right?
Really, it doesn't matter. You
Doesn't
can do
matter.
Yeah, thank you.
You can
It
do
doesn't matter. Yeah, you can do ascending or descending for both methods. Okay, please go ahead.
Yeah, so like I've said, we are going to capture one of the variable in an ascending order. Or not as oh my god, sorry. Not ascending order. It's called, what's that word? Chronological order. What's
Yeah,
that?
which is ascending. Yeah, the chronological order or array format can be ascending or descending, but you chose ascending. Yeah, sure.
Sorry, guys.
It's understandable. Keep going.
Yeah, I was saying, like how I understood it, we rank one in a chronological order. Yeah, like for example, where we have rank A, we can have 1 up to 6.
Okay.
Like 1, 2, 3, 4, 5, 6. Yeah. The other thing of match the other rank to the corresponding rank. So the other rank we have in question right now is weight. So we ask ourselves, when A was 1, what was weight? What position was weight?
It's also 1.
1. So we put a
1.
Okay.
When A was 2, what was weight? Which position was weight?
5.
5.
5.
When age was 3, which position was weight?
6.
6. When age was 4, which position was weight?
3.
3.
When age was 5, which position was weight?
4.
4.
And when age was 6, which position was weight?
2.
2.
So that's that's
Kindly do that again. I've not understood.
Number 1. Did you understand the ranking on the side ranking? 1, 2, 3, 4, 5.
Yeah, we got now one of the rankings, which was the age. We now just put from the smallest to the highest. So we put the 1, 2, 3, 4, 5, 6.
Yes, and then you
So
start
now
asking yourself. You see, we have 1 under RA, like age, rank age. Yeah, we ask ourselves, when age was 1, when age was like position 1, what was our weight? Our weight was 1. When age was the second, like when age was position 2, what was our weight?
the weight was 6.
No, look at the rankings we did on the side first. You see where we have 20 as number 1, 25 as number 2, 30 as number 4. Yeah. And then on the weight, we have 60 as number 1, 75 as number 5. So those are the things we're going to look at. When 20, you see we had 20 as number 1. Yeah.
Yes.
And even for weight, 60 was number 1.
Number 1. Yes.
When our age was number 2, 25, you notice that 75 was number 5. Was position 5. The corresponding rank is what you're looking at. Yeah. Then when age was position 3, what was weight? Weight was position 6.
I'm failing to understand that one. No, I'm still failing. Okay, 1 is 1.
Okay.
So we are looking at what we've changed into ascending order.
Can I help her? Just a second.
Yeah.
Okay. You remember the original figures?
Yes.
What is, when the age is 25, what's the weight?
The weight is 75.
Okay, now let's use the ranks. What's the rank of 25 under age?
2.
The rank of 25 under age is 2.
Perfect. What's the rank of 75 under weight?
It's 5.
It's 5.
So that's what she's trying to do. She's trying to match the original figures in terms of ranks. that when she had age as 25, the weight was 75. Now, in terms of ranks, age is the second. In terms of ranks, the weight is the fifth. So you're trying to move it in its original form, but in a rank format.
Okay, I now get it. Thank you.
Let's go to age. When age is 36, what's the weight?
70.
70. So when I have age as 36, what is its rank?
5.
5. When weight is 70, what is its rank?
4.
4.
So I should see 5, 4, like that. So this 5 is actually representing a 36, and this 4 is representing a 70. Does it make it better somehow as an addition?
When age is 36, we ranked it as number 5. And the weight at that time when we ranked was 4.
And the weight was what?
No, the age was at 36, the age was 5, and the weight was 4.
Okay. In other words, whether it is in ranked format or its original form, they should remain matched. When I translate these values into ranks, they should be corresponding.
Okay.
Okay. Yeah. Let's go to age 28. What is its rank?
3.
3.
28.
Okay.
3.
Uh-huh.
And the weight was 6.
No. The weight was?
The weight was 28.
The age was 3.
The weight
and
was 82.
When the age was 28, what was the weight?
It was
82.
82 and the rank was 6.
What's the corresponding rank in the age?
It is 6.
It's 3.
It is 3. Is it okay? So literally, in this RA and RW, you are matching the ranks. What distorts them is the RA, because it's been written in an ascending format, which is quite different from how it was originally written. I don't know if you can see it. Originally, it's written as 1, 2, 4, 3, 6, 5. But here she told us that we write it in a chronological order. From 1 to 6. Now, when you write it from 1 to 6, it means there is a change in RW. You need to match it. Is it
Excuse
okay?
me, Buzz.
Yes.
I'm still confused somehow. I don't know if, guys, I'm taking you behind, but the original ranking is still confusing me.
Okay. Very quickly, let me explain that. You see the original ranking of age? What is it? You read them for us. The ranks of age.
1, 2, 4, 3, 6, and 5.
Now, she said we have to write them in a chronological order, in an ascending format. And what did you write?
1, 2, 3, 4, 5, and 6.
So that order is different from the earlier one you wrote. So
Okay.
remember.
My question is,
Finally, should have understood Kendall.
When we are ranking it first, the first time we are ranking, do we follow like any okay?
You follow any, it can be ascending or descending.
Okay, I
when
could even say this is 1, this is 4, this is 5, this is 3.
no. When you're
Okay.
ranking it the first time, like where you see 1, 2, 4, 3, 6, and 5, okay? You remember we asked ourselves, are we going to use ascending or descending? And the lady told us you use either. So we
Yeah.
have ranked age in an ascending order, where you see the 1, 2, 4, 3, 6, and 5. Those figures in red.
Yes.
You've used ascending order to translate the original data into ranks. Now, you are going to write it chronologically, where you see RA. RA said is telling you, you write me in order from 1 in an ascending order up to my last. So you are writing 1, 2, 3, 4, 5, 6 against the first writing you had.
Yes, yes.
So when you are done with that, she told us that now start to match so that the data is not distorted even in a rank format.
Yes.
You see, you would like to maintain that someone's age watch that was 20, his weight was 60. But now they
Yes.
have positions. The age is position 1, also weight was position 1, which
1.
is here
Yes.
and there. The age was 25 and it was position 2. The weight
Yes.
now is 75 and it's position 5. So you remember you already wrote these two. So the question is, I need to look for its corresponding rank in
variable.
weight.
Yes.
In weight, its corresponding rank is 5.
Yes,
That's
true.
what the colleague did. Yeah. Does it make sense now?
Yeah, it does.
Yeah, so the disturbing point, if I got you right, is this point of RA. Because now you've rewritten the figures in an ascending format.
Yes.
And yet you want to match it with the other ranks of the other variable. So after you have ranked, get one of them and write it chronologically from 1 to the last in an ascending order.
Yes.
Make sense?
Yeah, it does. It really does.
Okay. I would like our colleague to proceed, please.
Okay.
No. Tutor and Mary, please. I have not. I would like to ask some question here because
Hey,
we
Kendall.
we're trying to follow the formats. I was trying to understand because from the ranking of weights, it was flowing well from when the age was 1, the rank of the weight was also 1, right?
Yes.
And when it was 2, the rank of the weight was also 5, which was okay. Now, when it was 4, the rank of the weight was supposed to be 3, but now I see they have written
Wait,
6.
brother, right
So
there.
where the confusion starts.
Right there, brother. Don't move away. You said when the age was 4, rank 4, okay?
Yes.
What's the rank of the weight?
It is 3.
3.
Good job. So let's come under rank A. Rank A is 4, you see it? And the rank weight is what? Is 3. This is the 4 you see here, and this is the 3 you see here. Okay, guys, let me explain this very quickly. I know what is disturbing us. What would happen, literally, is that you'll have a separate table, age, weight, a separate table of ranks. It's just that we put them in the same table. This is going to help you. Don't you worry. So I have 20, 25, 30, 28, 42, 36, and this is 60, 75, 68, 82, 66, and 70. Okay? Let's
I
run.
have a question.
1 second. 1 second. Please, you'll ask. Don't you worry. So let's rank in ascending order. Age, this is 1. This is 2. This is 3. This is 4. Pardon me if I'm going astray.
36
This is
5.
5.
36 is 5.
And this is 6. Okay? Underweight, this is 1. This is 2. Help me when I'm stuck. This is 3. This is 4. This is 5. And this is 6. Are you with me?
Yes,
Okay.
please.
I'm going to do something here. I'm going to remove this. Are we clear?
Yeah.
And these are just ranks. So I come to the rank age, and I'm going to write it chronologically. Okay? So I come here in my first small table of ranks, and I write age in ascending order. 1, 2, 3, 4, 5, 6.
Correct.
Now, I ask myself, when age is number 1, what is the number for W? This is A.
1.
This is W. W is 1, so I take it off. When age is number 2, what is W? Number 2 is here, W is here. It is 5. It's right there. Let me remove further. I'll remove this one. And I also remove this. Let's assume. So I pick one of them and I write it chronologically. So I write age. It can be age or weight. It doesn't matter. So this is first, second, third, fourth, fifth, sixth. Yeah, up to 6. My question is, when age is number 1, the weight is also number 1. When age is number 2, the age is number
The
5.
weight is 5.
The weight is 5.
Mm.
When age is number 3, the weight is 6. When the age is number 4, the weight is
3.
3. When the age is number 5, the weight is number 4. When the age is 6, right here, the weight is number 2. Does that make sense?
It does.
Exactly. This is how you would have explained it. This is not very okay.
I'm sorry, brother. Okay,
And
so
maybe
what
some
happened?
coming exams banange kuba
What happened is that we combined 2 tables. A table where we ranked and a table where we did a re-rank. Okay, so for purposes of clarity, you can separate them. You have your table of the ranks, then come in the other table and write one of the ranks chronologically and start to match them. Does it help?
It does.
It does.
Okay. I'd like the other lady to proceed, please. We go to C now.
Yes. But I'm asking, there are also scenarios where you find that in a column, there are like 2 same figures or 2 variables. Let me say you have 2 20s or 3 20s
Yes.
or 3 30s or 2 30s, but
Tied
then you have to
ranks.
rank them.
Yeah, those are tied ranks. We're going to see it. I'll talk about it quickly. Yeah, let her first finish.
Yeah, then divide by the name.
And also the other thing, what if I draw my second table when I'm answering the question under age? Like I write it in ascending order. I start from 20 as it falls in ascending order. 20, 25, 28, 30, 36, 42. Then I rank them like 1 to up to 6. Then I start comparing them with ranks with the weights.
Yeah, that will be okay. But you make sure that when you write, like for instance, I hope I got you right. When I write 20, 25, 28, 30, 36, and then 42, okay?
Yes.
I make sure that I match them with the weights. When the age was 20, weight was 60. When age was 25, weight was 75. When age was 28, the weight was 82. When age was 30, the weight was 68. When age was 36, the weight was 70. When age was 42, the weight was 66. Is it okay? In
Yes.
all respect, you must respect the original data.
Yes.
Do I make sense?
Yes, please, you do.
Excuse me, Baz.
Okay, good. Yes, please.
I think it's better for someone to leave them as is because the chances are high that you'll be on a rush and you forget to rearrange them in the right format.
This guy, because it's a ranking, this guy would like to see the ranks.
No, I meant
Yeah.
the lady who asked whether to rearrange the age in ascending order, and then she might forget to rearrange the
It's actually
weight to correlate to
Yeah,
the
sometimes it's
age.
best you leave them the way they are. Yeah,
actually
sure.
also do 60, 66, then 68, and then she mistakenly does 1, 2, 3. So at the end of the day, they
Yeah,
cross out and you're
sure.
doing this case.
But
Yeah,
when you
sure.
do that, won't you get like same ranks? Because
Auntie,
It
that
will turn out to be the same.
yes,
you
that's how I'm seeing it.
Yeah,
yeah,
you're
so
right. So you
as
might mistakenly make that error.
Exactly.
Yeah.
it as
Okay.
Okay, thank you so much.
Mm-hmm.
it,
Can the lady go ahead?
Yeah, she can go ahead.
Sure.
Yeah,
okay.
I'm done.
So at this hello.
Yes,
At
please.
this point, let's put our focus on W. At this point, let us put our focus on rank W because that's where C and D are going to apply.
Thank
Why
you.
not A? Because hello.
Yes.
Yeah. Why not A? Why aren't you putting our focus on A at this point? Is because A has already been arranged in a chronological order. So we are
Thank you.
looking out for the other rank, for which we put our basis on A. Like remember when we're ranking our W, we're asking ourselves when A was 1, what was W? When A was 2, what was this? So that what was this is where I put our focus on right now, which is rank W. And on that that rank is where C and D are going to apply only. Yeah.
Okay.
So C is I don't know how to pronounce them. I don't know whether concordant or concordant.
Mm-hmm.
Concordant and discordant.
So
Thank you. Yes.
concordant terms are the values that are more than the rank that is under comparison, or those that are bigger than the rank under comparison. Remember, our focus now is on rank W. So that's where we're all focusing. We start from the first one. We said C, these are values that are bigger than the rank under comparison. So we look at 1. The very first one is 1. Yeah. Let us look for values that are bigger than 1 under rank W.
We have 5,
But
we have 6, we have 3, 4, and 2.
How many are they?
1, 2, 3, 4, 5. There are 5.
Our C, the first one is 5.
Okay.
Uh-huh.
What with that?
So you said the first one is 5. I
Yeah,
hope it
5.
is clear.
Then, so when we are done with 1, we are not going back there. Next one, which is 5.
Next one is 5.
Okay, someone wants a pardon. Did you understand the point where we said our focus is now on rank W?
Yes.
Okay. And so right now, okay, basically concordant terms are values that are more than the rank under comparison. The rank comparison currently is rank W. Yeah. So we are going to look at the first, like we're going to look at a certain rank, and then we look out for the values that are bigger than that rank. For example, we have 1, rank 1. Yeah. We are going to look out for the values that are bigger than 1. You notice we have 5, we have 6, we have 3, we have 4, we have 2. We count them. They are 5. Yeah. So that is what goes under our C, 5. There are 5 terms or values that are bigger than rank 1. When we are done with 1, don't go back there. We now start from 5. Yeah? We
That
look
is
at
why
5.
there's only one number greater than 5, and
Pardon?
that is 6. There is only one number greater than 5,
Exactly.
and that
So
is 6.
We write 1.
We write 1. Yeah. We now forget about 5 also. We start from 6. Any number bigger than 6?
No.
So it's a 0.
Wait a minute. There is something I'm trying to understand, but I'm failing to pick it. You are like, you first compare the biggest number.
You're not comparing. Yeah. Put your focus on rank W. Yeah. Only. Don't look at A, don't look at anything. Just put your focus on rank W. We have position 1, we have 5, we have 6, we have 3, we have 4, we have 2. We are working on concordance. Yeah. And concordance are values that are bigger than the rank under comparison. Yeah. The rank under comparison, the first one is rank number 1. Yeah. We want values that are bigger than 1. Yeah. Do you see them? Values that are bigger than 1? The gentleman.
Values that are bigger than 1 in that
Yes, I can
entire
see them.
So
in that entire column from 1, 5, 6, 3, 4, 2. So which numbers are greater than 1 on that column?
Exactly.
It is the 5, the 6, the 3, the 4, and the 2. So you count them. The total is 5.
5, exactly. Is that clear, sir?
To me, it is. I don't know others.
Yeah, it's very clear.
So after, like once you're done working on a certain rank, forget about it. Like don't consider.
Yes, Madam Mary, Madam Tutor, I have a question for you.
Please ask before I does.
Yeah, so are we only looking at the number that are greater than in the column or in the row?
Yes.
Which one are we focusing on? Is it the row or the column?
Column.
In the
column,
column, and the column
but
has 6 numbers. The 1, the
with
5,
the
the
rank
6,
W.
and the 2. So out of all those numbers in that column, which numbers are greater than 1? You
1.
realize that all the rest of the numbers, the 5, the 6, 3, 4, and 2, all of them are more than 1, are greater than 1. So you count them, and there are 5 numbers. So you put under concordant, you put 5.
5. Is that okay?
I think you got it. Anyway, he should speak for himself.
No, I
Guys,
got
I'm
it.
okay.
I got
I'm
it from
fine.
5.
I got it.
Okay.
Okay, thank you.
So once you're done with 1, forget about it. Move on with life and go to 5. 5. Look at 5. From 5 going downwards, how many values are bigger than 5? You notice we only have 6. And it is 1. So we shall put a 1 because that is the only value that is bigger than 5. Yeah?
Yeah.
Move on with life again. Go to 6. From 6 to 2, how many values are bigger than 6? None.
0.
So we put a 0. Yeah? Forget about 6. Go to 3. How many values are bigger than 3?
1.
1. We go to 4. How many values are bigger than 4?
0.
And lastly, we have 2. How many values are bigger than 2? Down.
0.
Remember, you don't up. Tetudda amabega. You move on. Yeah? Don't go back to your X. So
okay. We shall
we
move
don't
on
have
with the
we don't have any value big 2, so we have a 0, guys.
Ebintu bya X ebyo bireke.
Mama, we continue.
Are we good? We go to discordant?
Yeah, we are good. I'm good.
So discordant are terms that are less or values that are less than the under comparison. We start from 1. Yeah? We look for values that are less than 1. Do we have any?
0.
Remember, this is under rank W, that column. So we don't have any value that is less than 1. We forget about 1. We go to 5. Do we have any values less than 5?
Yeah.
And how many?
Yes.
We have 3, 4, and 2.
And 2.
Yeah.
So there are 3 in number.
Yeah. We move on to 6. How many values are less than 6?
3.
There are also 3.
Mm.
We move on to 3. How many values are less than 3?
1.
1. Only the 2. We move on to 4. How many values are less than 4?
1.
1.
And then lastly, we go to 2. We don't have any value that is less than 2. So it's a 0. Then we get the summation for C and D. And we go put the substitute in the formula and the number is done.
Where have you been?
Thank you. Bulijjo atudda wa.
Yakunoonya.
That's a nice one.
But the value that are less than 2 is this. We also have 1. So why are you putting 0?
1 is less than 2.
Onazeeyo wa X omulaba.
Which one?
Isaiah, you're too funny. Okay. Go ahead.
Mary.
Explain.
Yes. Which one is less than 2? Remember.
1 is less than 2.
Remember I said. Remember I said.
Any number that you finished up, don't count it. Less than 2, below 2. Is there any number below 2 that is less than 2?
At this point, people just want to see
the number.
That must have enjoyed this one.
That is less than 2, but
Let
below 2.
me explain,
Remember, at least the last one. So
let me explain.
Guys, first let Tutor explain to me. I ask her a question I would like to understand.
Yes. So this is it. Yeah. Maybe Buzz, please help scroll up a bit.
Oh, sorry.
Once you're done with a rank, you don't go back to it. That is why when we said when we counted values that are more than 5, yeah. Okay. Let me say less. When we counted values that were less than 5, we did not consider 1. We only considered the ones that are following 5. like you start from that value you're comparing, going downwards. You don't go back up. Whichever you're done with, it's done. Like, don't consider it again. You get it?
Yeah,
Yeah, so that's why I hope it's clearer now.
it's clear.
Thank
Yeah.
you.
We even have a negative correlation.
Yeah, so yeah.
Thank you very much. Guys, I don't know if you have
Thank
any questions with it.
No.
I think she's done
A
it
great
justice.
job.
Yeah, you did really well.
Excuse me, sir.
You need to take her to Chikumi Chikumi.
But we have passed those standards of Chikumi now.
Sir, I just needed a small explanation.
Yes, please.
I think when Mary was taking us through that, I'd closed my eyes. Just a request. That explanation of concordant, that the 5, how did they get the 5? Just that that first letter, the rest I have understood.
Concordant, we said
Adriana Ngosik.
these are values that are bigger than the rank under comparison. Yeah? When we look at rank W, where we have 1, 5, 6, 3, 4, and 2, we shall start with 1. Yeah? Look downwards and look out for the values that are bigger than 1 or more than 1. You notice we have 5, we have 6, we have 3, we have 4, we have 2. Count them. How many are they? They are 5. So that's the 5 you see over there.
Okay, fine. That's I just needed to know. What I know is that the first value, you count the numbers that are more than
Yes.
1. Yeah. So I had closed my eyes. I just woke up already somewhere. Thank you. I've understood.
All right, guys.
Sorry for taking you back.
Okay, that was a nice one. No worries.
Thanks for making
Okay.
us understand.
Yeah, guys, thank you very much. I don't know how much to thank you for this discussion, but I would like you to re-emphasize. We have, I don't know, some people are doing financial accounting, so that we have Friday tomorrow, Saturday, and Sunday. I would like you to utilize those days really well. For the hypothesis tests we haven't done, please go try out the questions I shared. I'm trying to see how I respond through voice notes. And where possible, when someone shares a question, I may be tempted to start writing and share answers. But when I give guidance, try to work out and then share in the group. So between tomorrow and Monday, get your notes book and read it from the first page to the last, trying out those examples. Do not go to the exam without doing the examples we did in class. Whatever the example looked like, kindly run it, understand the examples, understand your notes. It will be very, very disturbing if a question is picked from your notes and you're unable to attempt it. Okay? So kindly do. I don't know how much to re-emphasize, but I know you are doing your best. So please, questions that will be coming throughout, try to attempt. There's someone who has asked about test for goodness of fit for normal distribution. I'm going to give guidance most likely tomorrow morning, but I'll make sure I get back. Okay? Yeah, so I'm monitoring the questions that you send. I'll endeavor to respond. But I just wish you nothing than the best. One thing you should go with is, guys, confidence. That's all. And then your poachers of marks. Don't try to say this is my best question, I should score 100% with it. Well, you are leaving another 80 marks behind. So kindly try to watch out for the time. This time is part of this exam. So the examiner will try to trick you here and there to eat up your time, but try to keep track of the time. If you don't have a watch, try to borrow one. Have something where you are timing yourself so that we can easily follow through with time. Time is part of the exam. The rest you may have prepared well, but timing, you get it wrong. People try to do the chapters they are very good at and they take a lot of time on them while wasting on the time for other questions. So kindly, I just call on you. You are capable of achieving. Actually, for the first time, I feel I'm going to have 100% pass rate. I just feel it with your classes. Yeah, so you could be the first ones. So kindly, you are capable of achieving no matter what. If you've been looking down at yourself or self-pitying, please, you can catch up in these 3-4 days. You can still make it. I believe that. So concentrate and try to do your private reading. Don't do
I have
so
a
many
question here,
discussions.
sir. I have a
Yes.
question for you here.
Yeah.
So, while attempting the exams, in an event that we have a lot of things, and as we're doing financials and also all these, the readings are quite many. So, what
Yeah.
happened? Can I just go with if I cannot remember some of this theory, can I just go for calculations only and then I leave out the theory parts? Can I say
Yeah. Someone actually did that in the mock paper, and he was just a poacher. I just looked at him and I was like, yeah, okay, now, yeah, that's it. You can go with the calculations and then come back. I'd someone asked me how to, score that extra mark. Guys, this is the thing. I already guided you on when you're doing the mock. When they give you the paper, do not rush to read through. The first page you will read is the formulas. When they tell you can now open the sheet, you go at the back and read the formulas. I gave you the reasons. The major reason is to calm you down. When you read a formula, it's like the guy has given you an answer to some questions. So you are not alone. You have support. That's the imaginary confidence you get. So fast forward, you win it there. Then number 2, as you read the questions, start with the required. Remember the chapters we wrote on the board. I tried to write for you. Make sure those chapters are on your fingertips. It's confidence building. Just make sure you have them. Make sure you are good at indices. You remember that missing figure thing? Make sure you are good at them. Make sure you can do a number in correlation and regression analysis. Make sure you can do a number in time series. Make sure you can do a question for graphing. What do we need? Of the 20 marks, we need 3 questions where we are scoring 12. Three questions where we are scoring 12. 12 times 3 is 36, right? From the other 2 numbers, we need 10, 10. From the other 2 numbers, we need a 10 and a 10 to make 56. Now, you guys do not deserve 56. You deserve a minimum of 65. Okay, so kindly, even if on the other questions, on the other 2 questions, you scored 8 and 8, that is 16 plus the 36. We make a 54. Now, how do you get those marks? You get them by not doing everything. A person who does everything will do 3 questions. I'm being sincere. Who tries to do everything, you'll do actually 3 questions. But a person who tries to do part of the questions will do everything. In other words, you'll have the 5 questions complete. Even with you, you can say this question, I have 8 marks. This one, I have 12. And on Jimazeyo, I have 20 marks. So people, yes, please.
when those guys are marking, when we're doing FA, they said they mark entry. So you do your entries, you write right, knowing each entry is a mark. Is it the same here?
Yeah, pretty much. Yeah. Like for instance, in this table, when I come to mark this table, if the final answer is wrong, I come to the table and I try to mark each entry. That's what happens. But they do not mark formulas. The examiner does not mark a formula that he gave. He marks the substitution into the formula.
Okay.
You get what I mean?
Okay. Get.
Yeah. So kindly try to plan your work. A number should not take you more than 32 minutes. In totality, you have 36 minutes on each question. Do not take too much time. Once 30 minutes elapse, you are about to drop that question and go to another one. Even if you are writing its final answer and it is 32 minutes, you leave it and go to another question. They'll mark those figures. You go to another one. Because each time you derail, you are derailing another question where we should be scoring. Okay? Now, when you get into the paper and you don't know number 1, it doesn't mean you don't know number 5. Read through all the questions before you start and then rank them what you are going to start with, what you are going to start with. We start with the best mark, the best question. I showed you questions to start with. Let me tell you, even if you are good at simplex tableau and it's your best question, I advise you don't start with it. When you see a question with graphing, when you see a question with indices, correlation, regression, I advise you go there. Then you come back to that question of simplex, maybe after your first number. This is the simple reason. As you do simplex, some entries may not come through the way you wanted them. And you need to rub back and forth. That rubbing back and forth, you'll be like, the paper has just started, I seem not to know anything. Yet you know stuff. So that distraction, you wouldn't want it. Start with something smooth. If it means there is a definition somewhere in question 5, you go and write that definition just to help you get introduced into the paper. You need a starter pack. You need a starter. A vehicle, I'm sorry to use this, a vehicle, when you are starting a vehicle in the morning, you should not race it, but people race the car. That car has been silent for a while. So when you start the engine, let it warm first for like 4 minutes and then come back and race it. Someone cannot wake you up immediately and say, now you start to eat or you start to answer this question. No. That's the same thing you do to a brain when you start with a question that requires a lot of thinking. So start with questions that are smoother. You'll not need so much to put in. I'm sorry, I stopped you earlier, but there are questions where like interpretation, a question in simplex tableau, interpret the graph or interpret the tableau. Those are cheaper. Questions to do with hypothesis testing chi-square, hypothesis testing normal distribution. What I'm saying is try to be simple in answering and poach the marks. Poach for the marks. What you don't know, you leave, you go to the next one. What you're not sure of, you leave, you go to the next one that you know. Guys, you are able to do all that when you plan well in your first 15 minutes. Those 15 minutes are very, very important. They tell you that from this question, I'll go to this. From this, I go to this. This part in this question, I'll skip. This I'll not do. After this, I'll go to this other question. Yeah.
Buzz.
Please.
You talked about us using pencil for drawings. So all
Yes.
these confidence interval things, all the anything like a drawing must be pencil.
For confidence interval diagrams, you may not necessarily use a pencil because those are for interpretation purposes. The diagram is not mandatory. It is where the guy is the one asking you to construct. Okay, because for most of those confidence intervals, people have mastered them. Okay, someone can give it to you without reading the what? The table. Okay, so that's fine. You may not necessarily have to draw with a
Then for
pencil.
the graph,
The graphs are
for the
pencils.
graph, now like this graphical methods. You see how we write that like after shading
Those are pencils.
shading the unwanted area, then writing, let's say days, months,
No,
frequency,
writing
those
is
things.
in
Those are meant
pen.
to be written in pen.
Yeah, writing is in pen.
Okay.
Yeah. Okay, guys, lastly, please know you are good enough. That's all I can tell you. You are good enough. Ebintu byemusomye nabo babisetinze. Ekyo muyina okukimanya. So you enter an exam knowing that you are going to answer what you've been able to study. What you know has been examined as well. So there is something for you to write. I don't know if you have any queries for me. I'm going to endeavor to be available through this time. Let me know how to support you. Right. Check in whenever you can, and I'll be readily available to help. I beg to leave it at that. And it's been nice meeting all of you in your different capacities. I
We are the
appreciate the
lucky
moment we've
ones.
interacted. Yeah, I've been very lucky to meet all of you. Okay. Guys, success. I'll be watching. I'll be watching. So
You're the best.
Thank you for being such a
So
great
much,
tutor.
Banandi. God bless you. Oh,
blessings too. I look forward.
we have to look for you. Katumalize chipapula chino.
Nange jabanonya. Kale banange and success.
Thank you.
Please
Thank
try the
you.
questions I share
Have a
out.
good
I may
night,
get one
sir.
or two to put in for you. Try them. I already see some questions. Guys who have sent through questions, I'm going to try and respond most likely tomorrow after the holiday makers are here. Yeah.
It's okay.
Okay, thank you so much, Bart. May God bless you.
Okay, good people. Success and nice reading. Bye for now.
Thank you. Thank you.
Yeah, I've
Bye.
shared the notes that we've been able to do. I remain online whenever I can. I'll be here. Okay. Don't make me cry, please. Musule bulungi. Okay, guys, I appreciate everything and bye for now. Thanks for being part of Capital College.